This course section here is entirely optional, and you can skip this course section and just mark the individual lectures as completed manually if you want to get that completion certificate at the end, if you did go through the entire rest of this course. Because this course section is about React hooks and exploring React hooks. And if you reached this section after going through the rest of the course, you already learned about all those React hooks, how to build custom hooks, and so on. But this section can serve as a great summary section where you again learn about all those key React hooks and how they work in a couple of hours. And in addition, this section is absolutely for you if you completed my old React course, which started with class-based components for state management, so which did not focus on functional components only, or if you completed some other React course or you went through some other React resource which focused on class-based components and you now want to upgrade your React knowledge and you want to learn all about this amazing React hooks feature which React has to offer. Now for this in this course section, I am of course going to explain what exactly React hooks are, why we have them, which problem they solve, and most importantly, how you can use them. And we're going to dive into the different built-in React hooks React has to offer with functional components, of course, since React hooks are limited to functional components. And we're also going to explore the rules of hooks and how you can build custom hooks. So what are React hooks? If you completed this course before I updated it entirely in 2021, or if you finished some other React resource which did not focus on React hooks and functional components, then you don't know about React hooks, but you do know that there are two main ways of building React components. You can build functional components and you can build class-based components. Now, functional components, historically, without React hooks, were limited to outputting content. You could only use functional components for outputting something. They received props and returned JSX. You were not able to change some internal state in those components in the past. Nowadays you are, but in the past this was not possible. That's why we had two different ways of building components. That's why we had class-based components. And we still have those, by the way. You can still write class-based components, and there's nothing wrong with that. But with React hooks, you actually don't need to create class-based components anymore. But in the past, we had to do that because in the past, only class-based components could contain and manage state, which of course is important to change what your application shows on the screen. But the downside with class-based components was and is that they have more overhead, more extra code than functional components. Functional components are very lean. It's just a function that returns JSX. Class-based components need a constructor maybe to initialize a state. You might add extra lifecycle methods, and therefore class-based components can quickly grow in size. They also suffer from other potential problems, but they definitely are more code to write than functional components. But because class-based components were the only kind of components that could manage state, you had to convert functional components to class-based components if you wanted to manage state or if you wanted to add lifecycle methods prior to React 16.8. But with the release of React version 16.8 in 2018, React hooks were introduced. And React Hooks is a feature that now allows you to manage state in functional components and to kind of add lifecycle methods there as well. And I'm going to teach you all about React Hooks throughout this module. But as mentioned, of course, if you already know what React Hooks are, because you completed the most recent version of this course up to this point, then you don't need this module. Now, React Hooks are just special JavaScript functions provided by React.js, though you can also write your own hooks, and you will see this as well in this course section. And these special functions can only be called and used, therefore, in functional components. You can't use React hooks in class-based components. Now, to mark those special functions so that you don't accidentally use them in the wrong place, they all start with the use word. The built-in React hooks are all called useState, useEffect, useRef, and so on. And if you build your own custom hooks, they also have to be named like this, as you will see later in this module. Now, these extra functions, when called in your functional components, then add extra functionality, extra capabilities to your functional components. For example, with the useState hook, you can add the functionality to manage and change state in a functional component. And that's why React hooks are amazing, because with them, you don't need to switch between functional and class-based components. Instead, you can build your entire React application with functional components only. And in this course section, we're now going to dive into all those built-in hooks, how to use them and how they work, and we're also going to learn how to write our own custom hooks. Now, to get started with hooks, you find an extra project attached to this lecture here, which acts as a starting project for this course section. It's this starting project which we're going to use to dive into the different hooks, to use them, to learn how they work, and to then also write our own custom hooks. So this is a simple React project created with Create React App. It runs on a version later than 16.8, and that's important. You need to have React 16.8 or higher, otherwise you can't use React hooks. Well, and other than that, there's nothing special in here. It's just a normal React application with a couple of components I already built for you. So let me quickly walk you through what we have here before we start working with that and before we start using React hooks. We have our index.js file, which is pretty trivial. I'm importing index.css, which sets up some global styling, imports a font, sets up some, global styling for the font, for buttons, and that's it. And then here I render the app component, which is living in the app.js file. It's a very simple component, doesn't do much. It will do more later, which is why I have this extra component. But for now, it just returns the ingredients component, which we get from the components folder, there from the ingredients subfolder, and then from the ingredients.js file, which would be this file here. Now in there, I in the end have a div. I render an ingredient form component, which lives in the ingredient form.js file. And then I have a section where I render the search component, which unsurprisingly lives in the search.js file. And if we have a look at the ingredient form, then we see that this is a component that uses a custom card component, which lives in the UI folder. We'll have a look at that folder in a second. And in the ingredient form here, I do have my form here. I have a section, which is a normal form with a couple of inputs, 2 inputs to be precise, for a title and amount, with a button. And I'm also using React Memo here to wrap this component to avoid unnecessary re-renders, so that this component only re-renders when the props it depends on changed, and not always when the parent component changed. So not always when ingredients changed, but only when ingredients changed, and we're passing new props to ingredient form, which right now we're never doing. So right now ingredient form won't re-render when ingredients re-renders. That's just a tiny side note. You'll learn about React Memo earlier in the course in the component deep dive module. Now that's the ingredients folder. Well, almost. We also have ingredient list. There I'm just rendering a list of ingredients. Right now we're not getting any ingredients from anywhere, and therefore, we're not using this. We'll use it throughout this module, of course. And in the search.js file, well, there I also use React Memo for the same reasons I do it in the ingredient form. And I just output a search box, this input here in a card. And that's, of course, this box here at the bottom. I got a couple of CSS files there too. You can, of course, go through them if you want. Just a bit of styling to make this all look good so that we have a nice looking app to work with. Now in the UI folder, I prepared a couple of UI components like the card here, which simply wraps whatever we pass between its opening and closing tag and gives it this nice card look with these styles here. I got the error modal, which I'm right now not using, but which we will use throughout this module. And this is just using React Fragment. Then I render a backdrop there and the modal itself, where we can output a custom content, like a custom error message. We got a button to close that. Clicking the backdrop should also close the modal, but it will be up to us to wire up this logic. I'm also using React Memo here, and here I got some styles for that modal. And I have a loading indicator, which is just a spinner, which we can render to indicate that we're, well, loading data. So that is what we have here. These are the components I'm giving you, and right now this app doesn't do anything. You can enter something here, but hitting this button won't do anything, because now it's up to us to wire this up. And if you watch closely, you'll see that all these components here, they're all functional components. There's not a single class-based component in there. And we'll leave these components as functional components. So we'll not change that, because as you will now learn in this module, we can build an entire React app with just functional components with the help of hooks. Therefore, let's dive right in and let's learn about our first hook, the most important hook probably. Now, it is worth mentioning that I also touched on hooks throughout this course. So some of the hooks I'll dive deeper into in this module are hooks I already mentioned throughout this course, but then I always mentioned that we will dive into it later. Well, now is that later. Now we will dive in more detail. And let's start with the ingredient form.js file. There we have a couple of inputs. And one thing we typically would do here is that we bind the input the user enters to some state property, and we update that state on every keystroke and then send the value back into the input, right? That's that two-way binding you'll learn about in this course, and we did this multiple times when we work with inputs. I want to do the same here because ultimately it all starts in this app here with us gathering the user input so that we can make this add ingredient button work, so that we do something useful when this button is pressed. Now, if you wouldn't know about hooks, or if you would use React 16.7 or earlier, then you would have to transform this to a class-based component and use state and set state there. Now with React hooks, you don't have to do that. Instead, you can import something new from React by not just importing the default export, which is that React object, but by importing a named export, and that is use state. I mentioned that all these hooks start with use, and then they have various names. So here it's the use state hook. And this is a crucial, probably the core hook provided by React. It allows us to manage state in functional components. It works a bit different than state and class-based components, but we'll see the difference in a second. So how do we use it then? Well, we go into our functional component, and that's important. You have to use it in your functional component body. So let's say here, and we call use state. Now that alone doesn't do much though. Use state can be initialized with a default state, and that state can be anything. Can be an object, can be an array, can be a number, can be a string, a boolean, can be any value. It doesn't have to be an object, it can be any value. So here we could create a new state that should manage the input for the title and the amount. So let's create an object here. Again, doesn't have to be an object. I choose to use one here because I have two values which I want to manage. And that would be title, and initially it's an empty string, and amount. And let's set amount also to an empty string. Now, you could argue that this should store a number, and hence you want to set it to 0 or something like that initially. But actually, Managing this will be easier if we set it to a string because input elements, the values of input elements, are always strings. Even if it's of type number, we'll always get a string. If we would want to work with a number in our app, then we would simply have to convert that value whenever we use it. But when we fetch it, when we manage it, managing it as a string avoids some strange side effects where we might not be able to edit this value in the way we want to. So both values here are strings. And now, of course, the question is, what does this get us? What does this use state call do? Because just that alone, of course, won't set up a connection between, well, our state we're trying to manage here and our inputs. Now, use state actually returns something. This here might be complicated to read, but this in the end describes how this function, the use state function, is defined. And after this colon here, we see the return value. And we see that the return value actually is an array, and it's an array with exactly 2 elements. And that's important. Use state, this built-in hook, always returns an array with exactly 2 elements. The first element then always is your current state snapshot. And whenever your state updates, to which I'll come back in a second, this component will rebuild, so this component function is re-executed. And use state, of course, therefore also is executed again, but React internally saves that you already configured a state with the help of use state for this component and will not reinitialize it, but instead use state manages this state detached from your component, so to say, so independent from your component, so that the state survives re-renders of this component, so that the state survives when this component function gets executed again. And therefore, use state, this first value which is returned here, is your current state snapshot, and it's the current state snapshot for this re-render cycle of this component. This means that when you update the state, you'll get the updated state here. So you get back an array in use state, and that array has 2 elements, and the first element is always your current state snapshot, either the initial state, or if you changed it, the updated state. That, of course, leads us to the question, how do you change the state? How do you update the state? And that's where the second element in this array is helpful. As I mentioned, this array always has exactly 2 elements. First element is your current state snapshot. Second element is a function that allows you to update your current state. So this here, this strange looking thing, this dispatch thing here, that's a function that will always be a function which you can call with a new data for your state to update that state. So therefore, what we can do here, we can store this array with exactly 2 elements in a variable or in a constant here actually, because for this render cycle, it's not going to change, hence it can be a constant. And I'll name this input state. The name is totally up to you, but in the end here, we manage everything we need to manage for our, well, state for these 2 inputs here, hence the name input state. Now that we store our array with the state snapshot and the state updating function here in input state, we can connect it to our inputs. And there I'll use a similar approach I showed you earlier in the course with 2-way binding in the end, where we bind the value of this input to the current state snapshot so that we pass the current state back into the input, so to say. And I do this by simply referring to input state and then the first element. Remember, input state is an array with exactly 2 elements, and the first element at index 0 will be your current state snapshot. So that will be, well, what we want to feed back into the input. Now, of course, our state is an object, though, not a string. So for the title input here, I want to access input state 0.title, because our state is an object with a title and an amount property to manage, well, input for these 2 inputs. And for the amount input here, I'll therefore set value equal to input state for the first element, which is our current state snapshot amount. Now we feed the current state for the respective inputs back into the input elements. Of course, we also want to update the state when we type into these inputs though. And for that, just as we do it always, also in class-based components, we can listen to the onChange event, which fires for every keystroke. And there we get this event object. So here I'm executing an anonymous function in the end. We get the event object automatically and we want to update our state. And as I mentioned, we do this with the second element in this array use state gives us back. So here we access the element at index 1, which is the second element, and this is a function, so we can execute it as a function by adding parentheses here. Now here I'm on the title input, so I want to update the title. So what we do here is we simply pass a new object to input state to update our current state with this new state object. And there we can set the title property to event target value, because event, that's the change event, the target is our input field, and the value property then holds the value the user entered. So let me reformat that, and now repeat that same logic here for the amount input down there. So there we also add on change, but of course we update the amount field. So with that, if we save this and we go back to our program here, and now I enter apples 5 here, well, we see this generally works. We can type here, which is a good sign, which means we're feeding the state correctly back into these inputs and so on. But we also get a warning that a component is changing a controlled input of type number to be uncontrolled. So what's the reason for this warning? What's wrong about the way we're saving our state here? And why am I getting a warning about the input of type number, which is our second input, if I type into the first one? The way we use state is correct. We're passing in a state, we're getting back this array which we're storing in this constant. But the way we update the state is not correct. There's one super important difference when you compare use state and how you work with state and functional components to how you worked with set state and the state and class-based components. There's an important difference between these two concepts. For use state, as I mentioned earlier, you can manage any state. It doesn't have to be an object. You could just manage some text here. But here I decided to work with an object because I have, well, two types of state or two input fields which I want to manage. Now in class-based components, you always had to use an object, but there, whenever you call set state, whichever object you passed into set state was merged with your existing state. So there, if we passed in an object with a title property, it would be merged with our current state, and the amount property would not be lost, but simply the title property would be updated, and all old state would be kept. With use state, that's different. This updating function, this second element of our array, does update the state, but it does so by replacing the current state with this, which in this case means if we type into the title, our new state simply is an object which only has a title property, and we drop the amount property. Our new state is an object that simply doesn't have an amount property anymore. That's why I'm getting this warning that the input of type number is uncontrolled. That's our second input, and I'm getting a warning regarding that input when we type into the first input, because the second input, this amount input here, which is of type number, this of course refers to the amount property in our state. Now if we type into the first input, we update this state to now be an object which only has a title property. Hence the property we're trying to access on the second input, the amount property, simply doesn't exist anymore, and that's exactly what's causing this error. The solution is simple. When we update the state, we have to ensure that we don't lose any old data. That's now our responsibility because React doesn't merge that automatically for us. And whilst this might sound like a bad change, whilst this might sound like it should do that for us, you'll later learn why React actually doesn't merge this for us anymore. Because now we actually have more flexibility regarding how we manage state. If we decide to manage some object state though, which very well might be the case in many situations, we have to ensure that whenever we update it, we don't lose any old data. So when we update the title here, we also have to set the amount property and simply set it to our, well, current amount state, so to the unchanged amount state, by accessing input state 0, so the current state snapshot.amount, for example. On the other hand, when we update the amount, we should also make sure that we don't lose the title by also setting this to input state 0.title. Now if you do that, if you make sure that when you update the state, you don't lose any information, now if I type here, you see I get no warnings anymore, And of course, this button doesn't do anything because we haven't connected it anymore, but these inputs are now working correctly. Nonetheless, our code here, the updating code, is not 100% correct yet. Reason for that is that I'm accessing the current state snapshot on the first array element, and of course that does hold the current state snapshot for this render cycle of the component. But the way React updates the state, we are not having a 100% guarantee here that our current state snapshot actually is the latest state we committed. And this might sound strange, but due to the way React re-renders components upon state updates and so on, you could theoretically have a case where there's a lot going on your page, let's say a lot of animations or a lot of stuff, that React decides to defer a state update until there's less work going on, and therefore a user might be typing here into the title input before the latest amount input, because the user also typed in the amount input field a second ago, before that state change has been rendered to the screen. Now, it's very unlikely for this to happen, and in this simple application here, it will never happen actually. But in more complex apps, you could have a case where you're changing some state and your latest state change hasn't been committed yet, hasn't been rendered to the screen yet. Hence, if you have a new state change that also depends on your latest state snapshot, then you don't have a guarantee that this state snapshot has already been, well, committed or created, and therefore this here, accessing our latest state value like this is not the ideal way. Instead, this updating function, so this function stored as a second element in your array, has an alternative form which you can use. Instead of just passing a value to that update function, so to that function that sets a new state, you can also pass a function to that function, an anonymous function, for example, but it could of course also be a named one. And if you pass a function here, which of course has to return your new state value in the end, and I'm wrapping it at brackets here so that I can use this inline notation here, this inline arrow function notation, that after the arrow, this is the value we're returning, and we're returning an object here without the extra brackets. This would be treated as the function body, and this would simply be an incorrect function body. Now we indicate to JavaScript that this here is our function body, and this is actually the return value, which is just an object. So now we're returning that object, but in this function which we're passing to this setState function here, so to say, there we get an argument passed in automatically by React. And that's our previous input state, or whatever you want to call it. And we can omit these brackets here. So here, this function will actually tell React that we want to get the latest state that we set, even if it hasn't been fully committed yet for this render cycle. So now previous input state allows us to access this previous input state like this. And the difference to using input state 0 is that we're now not using the latest state which has been fully committed and which is used in this render cycle of this component, but that we're using the latest state we set with an updating function, no matter if React already recreated the function or not based on that last update. So now here we have the guarantee that we get the latest state at all times. And that's of course what we want here. And here I'm missing an extra bracket, by the way, to close that input state 1 function. So now this is the approach I also want to use down there for the amount input. We get our previous input state, and then here we're returning a JavaScript object, and in that object I can use that previous input state to set the title or the amount. Now with that, if we save that and we go back, you'll actually notice a strange behavior though. If you start typing, you'll get an error. And that error tells you that you reused an event, essentially. Now, the problem here is that when we're passing a function to this function here, to this setState function in the end, then we're having this anonymous function here, and that's a closure. So that's simply a function that closes over surrounding values. And in this case, it closes over our event here. The event is fed into this onChange anonymous function, and in that function which we have here, upon a change, we're calling the setState function, so we're calling a function, but then I'm also defining yet another nested function here, So we have function 1, which is our event function, and function 2, which is our updating function. Now the problem with that is that if in this inner function here, I use something from the outer function, which I'm using the event, then this event will be locked in for the first keystroke, essentially, which means that for subsequent keystrokes, we don't use the new keystroke event, but the previous one, which of course is then reused and which causes this error. Now, normally that wouldn't be a problem, of course, because yes, this inner function, this state updating function is a closure, and therefore it closes over the event object, which means it saves this event object for its execution so that when this inner state updating function runs, which happens asynchronously, we're guaranteed to use the event that was triggered for that keystroke, so that was created for that keystroke. The problem with events, and that's now really exclusive to events in React, just is that React events are not the native DOM events, but special synthetic events created by React, which basically replicate the native DOM events you would normally get, but React adds a special factor to that. It pulls these event objects, which simply means it reuses event objects. So instead of creating a new event object for every keystroke, it instead reuses the previous object. And the consequence of this is that for the second keystroke, since we have a closure and we locked in the event for the first keystroke, for the second keystroke, we still reuse that same object we had for the first keystroke. And that simply is the problem here. We're reusing the wrong event object because of the way React handles event objects. Now, I'm aware of this sounding very confusing. In the end, this is really a special case because of the way React handles these event objects. The solution is that outside of this setState function, we create a constant, for example, which we here on the title could call new title. And there I store event target value. Now this will be recreated whenever we're typing. And now we need a real function body though. So we need to wrap this into curly braces because now we actually have more than one line. We're not just returning something. We're not just executing one expression, but we have two statements here. So now here I'm storing the new title for every keystroke. And now this here, this setState function with this nested inner function can use new title. And this will therefore now close over this new extracted title for every keystroke instead of using that same event all the time, that same event object. Of course, we do the same for the amount. There, we now need curly braces around this entire function expression here. Then we get our new amount from event target, not title, but value here. And the amount now is simply new amount. Again, simply because we're using a closure here and we want to make sure that we're generating a new amount for every keystroke, and then this will automatically be considered by this inner function instead of reusing that same event object all the time. Now with that, we can save this, go back, and now start typing here, and that now all works. Now let me get rid of that dummy title output, and let's work on the overall syntax we're using here. Thus far, we're storing this array we're getting back in input state. And we can absolutely do that, but it means that we have to use input state 0 if we want to get the values, and input state 1 if we want to get the function to update the values. Of course, we can do that, but it's a bit of a hard to understand syntax. For example, that this is a function is not immediately obvious. We can use a modern JavaScript syntax to make that easier to understand. We can use a feature called array destructuring. How does it work? It allows you to pull elements out of an array and store them in separate variables. So here where you know that you get an array with exactly 2 elements, you can add square brackets on the left side of the equal sign. So by adding them on the left side, you're not using them to create a new array or anything like that. That would be the case if you use them on the right side. But instead, this now is a JavaScript syntax that allows you to pull elements out of that array and store them in variables. And you add as many variables here, variable names of your choice here between the square brackets on the left side as you have elements in the array. So here we have always exactly 2 elements. So we can add 2 values here with any names you want. The first element will be our data. So here that could be input state. and the second will be a function to update that data. Typically you name this set input state or set whatever you named your data, because you're, well, setting this to a new value. You're not merging it, you're not updating it, you're overriding it. So you're setting some new data. So now we're using array destructuring, and our input state will be our data, and that will be the function to update the data. That's way easier to use now. We can use input state here without the 0 to work with our data. And we use set input state instead of input state 1 to update our data. And I think that's much easier to read and to understand than it was before, to be honest. Now, if we save that, it works just as before, but now we have a syntax that's way easier to understand. A side note, of course, this button still doesn't do anything because we haven't hooked up any logic, but we'll do that step by step. So this is the syntax we'll actually use, and the syntax you see in the official docs, you'll see throughout the rest of this course, and the syntax which is much better to use when working with the use state hook. I hope it's clear how the use state hook generally works now. One thing which I'm not liking too much, however, is how complex it is for us to update this state. Of course, this is not a complex state here. It only has two properties, only two things, title and amount. But still, we have to ensure that when we update the title, we don't lose the old amount, and when we update the amount, we don't lose the old title. Now, obviously, that's doable here, but imagine that we had a longer form here. You would have to write a lot of code just to always save all the old state when you update something new. So whilst you can of course manage state that is an object, and whilst this often might make sense, you should also be aware that there is a huge important difference when you compare the state added by useState to the state you used in class-based components. In class-based components, state had to be an object and React merged it for you automatically. In functional components with useState, state doesn't have to be an object and React doesn't merge it for you. But what you can do is you can register multiple states. So what would make much more sense here is that you don't have an object, but let's say just a string here, and that this is your title, maybe your entered title to make it really clear what you're saving here, and then you have the set entered title function. And then we add another state here, which is our entered amount, and we have set entered amount here. And that's use state with an empty string initially too. So now I have two states which are both managed independently by React for this component, which are stored in different variables and which I can set with different functions. So now I don't have to manually merge anything because these are managed independently. So if I update one, the other one will be kept around and vice versa. Because as I mentioned already, these states survive re-render cycles. So they survive updates of other states. But we don't have to merge it manually because it's now an object anymore. But instead we have two separate strings which we're managing as state. So now here when we're working with the title, we could just output the entered title here. And here we're not calling set input state, but all we're calling, and that's so much easier, is simply set entered title. And we can pass in the new title here. However, we no longer have to store this in a separate variable. We don't have that closure problem anymore because there is no inner closure in this function anymore. Instead, we just call set entered title and set this to event target value. We don't have to manage anything, merge anything, because we manage this as two separate states. So the same here for on change on the amount. We just call set entered amount and set this to event target value. It's as easy as that. And if we save this, we still have the same behavior as before, but now in a much easier way. And this is actually my recommended way of doing this. Split your state into multiple states. That is how use state is intended to be used. And only use objects or arrays as values for your state if you really have data that changes together or where you need to change multiple things together. Otherwise, manage your state independently. It's so much easier. It's so much easier to write. You don't have to merge anything manually. It's a breeze to use it, as you can see. So we spent a lot of time on use state but it is the most important state React offers. React offers more hooks than just useState, but it really is an important hook. If we analyze it, then it's clear that the idea behind useState is that we can manage state in a functional component by calling useState with some initial state, which we can set up. You don't have to pass an initial state, by the way. If you want to have null or undefined as initial state, you simply pass no argument at all to useState. And this creates a state which is managed by React behind the scenes and which survives re-render cycles. And what you get back by useState is that array with exactly two elements. A pointer at your state, that's the first element, and a state update function, that's the second element. This is how useState works. Now there are two important rules when you work with hooks, with any hooks, not just with useState, but also with any other hook you'll learn about in this module. For one, you must only use the hooks in functional components or inside of other custom hooks, which we'll build later. The second important rule is that you always have to use the hooks on the root level in your component. Now, what does this mean? It means that you can't use a hook in some nested function. Here I have the submit handler, which isn't doing much right now, but we can't use useState in here, for example. And actually, we already get an error here because modern React projects already have code checks which determine that this here is using a hook in something that's neither a React function component nor another hook, and therefore it's not allowed to use it here. You're also not allowed to, for example, use a hook in some if statement. So if you had some condition and then you want to create some state, that's also not allowed. Here, unfortunately, my project doesn't determine that this is wrong, but this is simply not allowed. You must not use your hooks in a for loop, in an if statement, or in another function. Use it on the root level of your functional component or on the root level of other hooks. So that was a lot of talking about useState, but of course, as I said, it is important. But now let's continue and let's make sure that we actually can press that button and we do add this ingredient somewhere. So for that, in the submit handler, I want to submit my data. Now, let's say we're managing our ingredients not in the ingredient form, but in the ingredients.js file, in the ingredients component there. And just because I'm seeing it, here I'm creating that component with the function keyword like this. In ingredient form, I'm creating it like this, storing it in a const, and then by using an arrow function on the right side of the const, it's totally up to you what you want to use. Both creates valid functional components. Both has nothing to do with React hooks. So back in the ingredients function here, which we, just to avoid confusion, could also write like this. In this ingredients function, I have the ingredients form, and here in this functional component, I want to manage my ingredients. I guess that makes a lot of sense because there I will also later output the list of ingredients. So it is a component that has access to both our input and to our output later. So I want to manage the ingredients in there. This of course means that we want to add useState here because our list of ingredients, our array of ingredients, of course, will be some state that should survive re-render cycles that will change over time and where every change should re-render this so that once we do add a list to output our ingredients, well, we can actually see some change there when we add an ingredient. So in the ingredients functional component, I'll again use array destructuring to manage my ingredients and to have a set ingredients function. And in there, with useState, I start with an empty array. Here I use an array because ingredients, of course, will be a list of ingredients, and we will always update that list as a whole when we add an ingredient or when we later delete an ingredient and so on. So we got our ingredients. Now we can also import the ingredient list component from the ingredient list.js file, which I prepared for you. You can just add it here, ingredient list. And ingredient list, this component actually takes a property, ingredient, which is then output. And there, besides the title and the amount, I also want to have an ID. That ID is then used as a key. So in ingredients.js, I want to pass ingredients, this prop, which ingredient list expects, to ingredient list. And the value here will be my ingredients up there. Now, can be confusing because it's always the same name. So maybe we name this up here user ingredients and name this here set user ingredients. You don't have to rename this just because you renamed that, but to really make it clear that these two belong together, I like to have the same names just with a set in front of our updating function here. And now user ingredients is what I pass here to the ingredients prop. So I hope this is clear which ingredients is what. That's the prop of the ingredient list. So we're passing this in here. Now the ingredient form should be able to add a new ingredient. So let's define a function here in the ingredients functional component, add ingredient or add ingredient handler maybe, and that's a function which will ultimately receive a new ingredient here, which should store this in our ingredients array. So here the idea will be to call set user ingredients, and now important, we'll need to update the existing list of ingredients and add a new one. Now that means we depend on the current state, and therefore it's best if we use the function form where we're guaranteed to get the latest state. So we get our previous ingredients here, our old array basically, the current state, the most recent state of this list here, and we return a new array where I use all previous ingredients. This is a spread operator taking all elements of our old array and adding them as elements to this new array, which I'm constructing with the square brackets. And then I add one new element here, and that's the ingredient we're getting. Now important, the ingredient we're getting from the ingredient form will have a title and an amount, but probably not an ID because the ID should be somehow auto-generated. Now I'll later use a web server which does this for us. For now, let's create a new object here with an ID, which for now can just be moth random to string. And that's not truly a unique ID, but unique enough for our cases here. It's a good dummy ID. And then I, of course, want to keep my title and my amount from ingredient. And we can again use the spread operator on ingredient now. So on this argument we're getting, because this argument will be an object, let's say, the spread operator then takes all key value pairs from that object and adds them as key value pairs to this new object. So now we're adding a new object with an ID, title, and amount to our list of ingredients here. That's the add ingredient handler. Now we need to pass a pointer at that add ingredient handler to the ingredient form, because that is where we want to trigger the addition of an ingredient, right? Because that's where we have our button that, well, submits this form. This button is of type submit, therefore it triggers the on submit here and the submit handler. And in here, I now want to, well, call something which I'm getting from the ingredients component. So let's say we pass in a prop which could be named on add ingredient, and the name is totally up to you. And there we point at the add ingredient handler. So this is how you pass function references down to components, right? You learned that throughout the course. Hasn't changed, has nothing to do with React hooks. So now we'll have an onAdd ingredient prop in the ingredient form, and that will have a pointer at this function. So in the ingredient form, in the submit handler, we can call props onAdd ingredient as a function, because again, this will hold a pointer at that function in the ingredients.js file. And there I will pass in an object, because here I expect to get ingredient as an object. I pass in an object which has a title and amount. So here, title is my entered title, and amount is my entered amount. Just like that. So this is getting sent to the add ingredient handler. This will add a new ingredient and update our ingredients array. And we're passing this ingredients array to the ingredient list. So now our hope would be to see changes in that list when we add an ingredient. So here's our ingredient list. Now let's add 5 apples, and we're getting an error. Now this error is coming from the ingredient list. There I'm registering a click on the ingredients to bind to onRemoveItem. That is something we'll need later to remove ingredients. So for now, let's simply go to the ingredient list component we're using in the ingredients component and pass the onRemoveList prop in there. And this should point at a function which for now simply doesn't do anything, just so that the ingredient list does receive a function and bind therefore does work. So with that, let's try this again. Let's add 5 apples, and here they are. Now clicking on them doesn't do anything for now, but we can now add our ingredients. So enough about useState for now. Let's now send this to a web server so that we can also dive into some other hooks, for example, hooks that help us replace class lifecycle methods. For this, I'll again use Firebase as a dummy backend. We'll just create a new project here, React Hooks Update. You can name this whatever you want. Create this project here, and I'm just using Firebase here because I don't want to write any complex server-side logic. I just want to have a server we can talk to, which automatically has a database attached to it, so that the data also gets stored there. So let's wait for this to finish and then dive into this newly created project. And in there, go to Database, and now make sure to set up a new database there. And don't use Firestore, but scroll down a bit and use the real-time database. Click on Create Database and start in test mode, which means that everyone is allowed to read and write. Because here we'll just use this as a dummy backend. This is the URL you can now send requests to store data in that database. And to send requests, we can use Axios, as we did in this course, or we use the built-in Fetch API, which is built right into JavaScript. It's totally up to you what you want to do. To mix things up, I'll use the Fetch API built into JavaScript. So when we're adding an ingredient, besides updating this locally, I also want to send an HTTP request. And I do this by calling fetch. And again, this is a function the browser understands. It's not a React function, not a React hooks function. It's a browser function, so to say. The fetch API, as it's called, is built into modern browsers. This will send a behind-the-scenes HTTP request. And fetch takes a URL you want to send the request to, which is a string. In our case, that's not just this URL, but let's say we want to store the ingredients in an ingredients node, and Firebase then also requires a .json at the end. That's just a Firebase thing, nothing to do with React, nothing to do with React hooks. So this is where we want to send our data to, and you gotta know that fetch by default will send a GET request. Firebase wants a POST request though, if we want to store data. Hence, we pass a second argument to fetch, and that's an object that allows us to configure this request. And on this object, we can set the method property to post. Default is get, and you never need to set that, but we want to set this to post. You then also can add a body property to define what you want to send. And that has to be JSON data, which means you can use JSON, which is another thing built into the browser. It's a class in the end built into browsers, which has a stringify method. This will take a JavaScript object or array and convert it into valid JSON format. It's a convenience feature built into the browser. Also has nothing to do with React. So here, I want to pass that ingredient we're getting. Basically ingredient like this without an ID, because now Firebase will generate an ID for us, so we don't have to do that manually. Now, one other thing you also need to set now is headers. This allows us to set our own headers, and that in turn is a JavaScript object, a nested JavaScript object. And there you can set headers you want to append to this request, and there Firebase expects the content type header and set this to application JSON. With Axios, we didn't have to do that because Axios did it for us. Fetch doesn't do it for us, just as it doesn't convert data to JSON for us. So we have to do the data conversion manually. We have to add this header manually to inform Firebase that we got some incoming JSON data. And fetch will now return a promise, which will eventually resolve once this request successfully was sent, or of course once it fails. That could be an option too. Now, let's say we want to update our data locally when this promise is done. Then we can use then here and get the response inside of this nested function. And in there, I then want to update my ingredients, because as you learned throughout this course, with promises, the thing is that the function you're passing to then will not execute immediately when this gets executed, but only when this request is done in this case. So then I want to update my ingredient. You could also use async await here if you wanted to, of course, but I will stick to this then approach because I think it makes it really clear that this executes at a later point of time. Now, the good thing is here, by the way, this response actually will get some data back from Firebase which contains that automatically generated ID. Response itself, however, is a more complex object. We're interested in the body of that response, and you get that by calling the JSON method there. This will extract the body and convert it from JSON to normal JavaScript code. However, this also returns a promise, so we'll actually return response JSON here and move this code into another then block, which I change here, which will be my body or my response data. I get this in this function here, which I pass to the second then block, which executes once this body has been parsed. And now response data will be an object which has a name property which contains this automatically generated ID. That's just how Firebase works. So here we can now set ID equal to response data.name. Again, that we can access .name here has nothing to do with React or with the fetch API. That's just Firebase. It returns some data, which in the end is a JavaScript object, which has a name property, and that name property will have that unique ID which was generated by Firebase. If you're using a different API, this will probably not be named, but for Firebase it is. And now we're creating our ingredient locally. We're updating it there based on our previous ingredients with that ingredient we got here and with our name, with our ID generated by Firebase. So let's see whether that works. Let's save that. Let's go back to our application. Let's add 5 apples. And you see it takes a while until it appears here, which makes sense because we're sending a HTTP request. And then here we indeed have ingredients added, and this is this unique ID. And if I add bananas, 10, again, it takes a while, not that long because Firebase is very quick, but a short while. And we also see it here. So that's working. As soon as we reload, though, all data is lost. So the next goal is to fetch our data whenever we reload. So whenever our app starts or whenever ingredients gets rendered, so to say. And for that, we normally would have used lifecycle methods. We would have used component did mount. And we can't use that anymore here, unless we transform this to a class-based component, of course, which is not the goal. But React Hooks got us covered. So we wanna fetch all ingredients whenever this ingredients component gets rendered in the end. Now, as I mentioned at the end of the last lecture, normally we would have used component did mount for that to fetch something when this component mounts. But this is now not an option anymore, unless we transform this to a class-based component. But there is another hook that helps us with that. It's the use effect hook. How does it work? Just like use state, the same rules apply. You can only use it in functional components or other hooks, and you have to use it on the root level. So let's maybe use it here. Use effect. Use effect has the name because it is there for you to manage side effects. And HTTP requests are a typical side effect. Side effect basically means that you have some logic that runs that does affect your application. For example, we are fetching some data here, but it's not getting finished in this current render cycle, or maybe it affects something which is outside of the scope of your JSX code down there. Maybe you're setting the document title, anything like that. So anything you cannot manage with your normal this component is getting rendered flow. Use effect, and that's important, by default gets executed right after, important, after every component render cycle. So after this component has been rendered the first time, the function you pass to use effect, because you have to pass a function there, will get executed. So this runs whenever this component got re-rendered. And that's really important to keep in mind. After and for every render cycle. These are the two important pieces. Not before, not simultaneously, but after and for every render cycle. Now, why do we need use effect though? We could just call fetch to get our data, like this, outside of use effect, right? We could call fetch, point at this URL, it will automatically send a GET request, and indeed, therefore, we will get our data back. And then we can add a then block, we'll get our response, and we can return response JSON to get access to the response body. And we can add another then block, which is our response data. And yes, we also should handle errors, we'll do that later. So here we got our response data. This gets executed when this component renders, and that is what we want, right? When this gets rendered for the first time, we want to fetch this. So here we got our response data. And response data in Firebase case will actually be an object, not an array. So we'll have to transform this. Our loaded ingredients, let's say, is an empty array. That's a helper constant here I'm creating. And then I use a for in loop to go through all my keys in that response data, because again, response data will be an object. Every key will be, and you can basically see that object here, every key will be such a unique ID, and the value for that key will be the actual data for our ingredient. So we'll have that overall object with these ID keys here, and then these nested objects. So here a key will be this unique ID, and the value for response data key will then be our concrete ingredient data. So therefore here I can use loaded ingredients, that array I'm creating here, and push a new ingredient onto it. It's constant, but with push we're not editing the value stored in loaded ingredients, we're editing the array stored in memory. And if that's not clear to you, attached you find a resource on JavaScript reference and primitive types, which have something to do with that. So here I push a new object onto this loaded ingredient array. The ID is that key, and the title is response data for that key with this dynamic syntax here, dot title, and the amount is response data for that key dot amount. So this is how I load my ingredients, how I transform this object to an array. And once this transformation is done, so after this for loop here, we can of course call set user ingredients and set this equal to the loaded ingredients, so to this array we generated. This approach has one huge issue. If you save this, you actually end up with an infinite loop here. You can see this if you access the network tab. You're sending tons of requests, and therefore I'll quickly comment out this set user ingredients line here so that this reloads and we stop sending this. So why are we entering an infinite loop here if we're fetching data like this? If you fetch data right here in your render function, then whenever ingredients renders, you're sending a HTTP request. And when you then, as a result, after this HTTP request, update your state, what happens if you update your state? Now the component renders again, so ingredients renders again. And what does this mean? We send another HTTP request. What does this mean? We update the state at some point. What does this mean? We re-render. We send another request. We update the state. We re-render, and so on. So that's the infinite loop. That's why sending this here is not an option. So let's cut this here, and let's instead move it into this useEffect function here. Now if I comment this back in, now we're executing this after every render cycle, but still, by default, for every render cycle. And hence, unsurprisingly, if I save this and we go to the network tab, we still have an infinite loop. So again, let's comment out this here and save this to update our page and stop that loop. So how can we fix that? useEffect actually also takes a second argument. The first argument is this function which it executes after every render cycle. The second argument is an array with the dependencies of your function. And only when such a dependency changed, only then the function will rerun. So this allows you to control how often this function runs. By default, for every render cycle, but you can change this. Now here, we actually have no external dependencies. And with external dependencies, I mean variables or data you're using, which you define in your component outside of the useEffect function. We're not using anything of that. This URL is hard-coded. Response is a variable created here on the fly. Response data, loaded ingredients. It's all created on the fly. Set user ingredients, that's actually a function stored in a variable coming from outside. But that's a special function since it's generated by useState. React automatically creates it such that this function never really changes and doesn't have to be considered as a dependency. So that's an exception because it is a function generated by useState. And therefore, this useEffect function here actually has no external dependencies, and so we can add an empty array. But we have to do that. Omitting it is not an option. Then this runs for every render cycle. If you do add an empty array, though, what happens is that this now runs when this component gets first rendered. So it runs this one time. It's not omitted entirely, but it runs one time, but it never runs thereafter. So with an empty array, it's like component did mount. Can kind of memorize that. With an empty array as a second argument, the function you pass to useEffect is like component did mount. So if we save this, now if we go to the network tab, we see no ongoing requests down there, and we see our data was loaded though. So if I again save this, you see our data gets loaded. So this is now working with the help of useEffect. So we learned about useEffect. Just like with useState, you can have multiple useEffect calls in one and the same component. You can have as many as you want, just as with useState. So here I could have another useEffect call, and in this function I just want to console log rendering ingredients. I'm not specifying a second argument, and therefore this will run for every re-render cycle here. So if I now save this, you see it runs twice. Reason for that simply is this component gets rendered, and then this first effect also executes and goes ahead, fetches data. So that's the first render cycle. And then once this data fetching is done, which happens in the future because it takes a while, only a few milliseconds, but still, then we update the state and hence we re-render this component again. And therefore we have another render cycle, and that's why we see rendering ingredients twice here. So you can have multiple useEffect calls, and you can control how they execute with this second argument, with this array. Now, you should configure this array in an honest way though, so you should really specify your dependencies. If you have a dependency, like for example, here I'm outputting user ingredients, then you should specify it. You can of course omit the second argument if you know you want to run this for every re-render cycle, but if you know you only want to run this if this changed, then you should specify that in this case, user ingredients is a dependency of the second effect. And this means that this function here will now only run when user ingredients changed. Right now in this app, that's the same as running it on every render cycle. But if we had something else that could be executed, which also re-renders this, let's say we had some other value we're managing in there, which we can change with a setState call in the end, then this function would only execute if user ingredients changed and not if that other value changed. And we'll see that concept of having arguments here throughout this module because it is very important. So that's useEffect and how you can configure it, or at least the basics about useEffect. But there's more to useEffect than what we see thus far. Let's go to our search component. The search component should be responsible for this input field, where we, for example, can enter apples, and then we only see, well, the items that match this name. And we're doing a full name search here, so we'll not search for app, but apples gives us all apples, bananas gives us all bananas. That's the idea here. Right now this doesn't work, of course, because the search.js file is pretty empty and has no meaningful logic in there. It's time to now change this with the knowledge we gained thus far. First of all, let's make sure we manage the user input. So we can, add an import to use state here, like that. Then here again use array destructuring to have the entered filter, let's say, and set entered filter. And then use state with an empty string and bind this down there, bind the value to entered filter, and bind on change here to a function that updates set entered filter. We get the event automatically passed in by React in the end. And then we call set entered filter and we set this to event target value. So that's something we did before already. It's just saving the value here. But now the idea is that whenever a user types something here, we try to fetch filtered data from Firebase. How could we make this work? Well, you could register a function for onChange, which basically sends a HTTP request on every keystroke. Would work. Here, however, I'm updating the saved value on every keystroke, and instead what we can do is we can use useEffect here, add it here, and pass in a function that should make that HTTP request. And we simply specify entered filter as a dependency. And this means this function will execute whenever entered filter changed. So it's having the same result, but in my opinion, it's a bit more elegant because we're really embracing the idea of hooks here, we're splitting our logic. This function only updates what the user entered, or only updates the state where we store what the user entered, and then useEffect will automatically execute thereafter and do whatever we want to do for every change. So here I want to send a HTTP request, so I'll go to ingredients.js and basically fetch the logic I have in here for fetching the requests. So let's grab that, copy it, and add it here into useEffect. URL is the same, transformation is the same, but of course in the end I don't call set user ingredients, but instead I want to trigger something in ingredients.js, right? Because that is where we manage our ingredients. That is where we also use the search component. So in the end, we should establish a connection between search and this ingredients component to update the ingredients here whenever we fetch new ingredients in search.js, let's say. Now, of course, typically for that, we would use props. So we can specify, let's say, props onload ingredients. Name is totally up to you. Call this as a function and forward our loaded ingredients like this. So onload ingredients is now a function I expect on my search components. So in the ingredients component, we have to specify this prop on the search component and there forward a pointer at a function that should execute when onload ingredients is called in the search component. We have no such function yet, so let me add a new one, maybe here at the very top. I'll name this filtered ingredients handler or whatever you want to call it. We get our filtered ingredients or whatever you want to call that as an argument. And the idea here is simply that we call set user ingredients and we set this equal to our filtered ingredients because these should already be in the right format. So a very simple function, and I'm passing a pointer at this function to onload ingredients on the search component so that we can call this function from inside the search component. So now back in the search component, we're calling this. Now with that, we have an effect that runs whenever entered filter changes, but now here we're getting a warning. In the end, the problem is that we're relying on props here, but we haven't specified them as a dependency. And that means that if props changed, this component will re-render, but this effect won't rerun because we haven't informed the effect about the fact that props are a dependency. Now you might say, well, I'm only pointing at a function here. That function shouldn't change. So actually that shouldn't rerun if props change. Well, you should never cheat regarding your dependencies. It's a good practice to always be clear about all dependencies you have. And here, props is a dependency, but still we'll have a problem with that. Now this effect will rerun whenever props change. That basically is the case whenever anything passed to this component here changes, or whenever anything in the parent component changes. That's also not what we want. We only want to rerun this function if onload ingredients, so if this function we're pointing at, if that changed. And for that, we can use another modern JavaScript syntax, maybe right here at the very top. We saw array destructuring. There also is a concept called object destructuring. Works in a very similar way. We have curly braces in this case on the left side of the equal sign. On the right side, we have the object, which we want to destructure or from which we want to extract properties. And then here between the curly braces on the left side, you specify the names of the keys in that object, which you want to extract and which you want to store in separate variables. So in my case here, that would be onload ingredients. I know that this will exist as a key in props. I'm calling it here. And now I'm simply pulling that out and storing it in a separate onload ingredients constant. So this is now a separate constant. And here we can just call onload ingredients. And we can specify onload ingredients as a dependency now. And now this will only rerun this effect if exactly this value changed. So if anything else in props changed, this will not rerun. Only if this function changed or if the entered filter changed. In these cases, we'll send a request here. And this request will get our data, then call onload ingredients in the end, and that should set our ingredients here. Now, our request right now, however, is not taking the entered filter into account. It's fetching all ingredients. Of course, it should fetch filtered ingredients instead. Thankfully, Firebase supports filtering. We can append some query params, which I'll store in a separate variable here, to the end of this URL. And I want to have different query params depending on whether we entered something or not. So if entered filter length is equal to 0, then my query param will be nothing. I'll not add any query parameters. So it's just an empty string. Otherwise, it'll be a string for which I use backticks here. So these are not single quotes, but backticks, so that we can use string interpolation to dynamically inject values here. And then you should add question mark order by, written like that, equal double quotes, opening and closing, and between the double quotes, the field for which you want to filter. In our case, that's the title field. Then ampersand equal to, written like that, equal sign, double quotes, opening and closing. And now with string interpolation, which is done with $sign and then opening and closing curly brace, the value entered in entered filter. This sets up query, which is either an empty string or this string here. And this is simply a syntax, a combination of query params understood by Firebase to in the end filter the title field for the value entered here. We have to append this at the end of our request here. So we can simply add plus query here in the end. And that's either that empty string or that valid query setup. Now to make this work, we need to also make a tiny adjustment here on Firebase. Go to rules in your database. Now we need to add an entry here to unlock filtering. Add double quotes here after this read-write thing. And there add ingredients. So basically the name you have as a node here you're sending your data to. Ingredients. And then the value is another object in the end with opening and closing curly braces. And in there add another string with double quotes, dot index on, which is a command understood by Firebase. And then this is an array, again with a string value in there, which is basically the field name by which you want to be able to filter. So you need to add this setup here to your Firebase rules. With this setup, we can filter for the title. Now we can send requests here. Now a request should be sent whenever we type something here. So let's now save that. Go back to our app. And you see, oh, we seem to be in an infinite loop again here. So to leave it, let's comment out onload ingredients and save this and reload. What's causing this infinite loop? In the end, this infinite loop here is caused by this onload ingredients dependency. This effect, which fetches all our data, will run whenever entered filter or onload ingredients changed. That will be the case for the first time search is rendered, so it will definitely fetch our data whenever search is rendered. But thereafter it will rerun whenever entered filter changes, which we never changed because that would only be the case if you type here, or if onload ingredients changed, which we're extracting from our props. That is the case if the parent component is re-rendered. The parent component is re-rendered because in the end, the first time we loaded data, we were calling onload ingredients, which calls this filtered ingredients handler function. And in there, we're calling set user ingredients, which changes the state, which re-renders this component, which means that here, of course, we're also creating a new filtered ingredients handler function because this entire component reruns. And in the end, this is just a JavaScript function, right? So even these functions you have in there, they still rerun, they're still executed again. In the end, this is just a variable which now receives a new value. Of course, we know it has the same logic as before, but technically it's a new function object in JavaScript. So it's a new object, we pass that to onload ingredients, and since it's a new object inside of the search.js file, this is different to the last time the effect executed, and therefore it will re-execute the effect. Because we re-rendered the parent, all these functions are created new, and, well, we got a different value, we rerun the effect in the search component. To prevent this from happening, we can use another hook provided by React. That's the use callback hook. The use callback hook allows you to wrap one of your functions with it. Let's say this function. So on the right side of the equal sign, you use callback and simply wrap this around your function definition like this. And now you also pass a second argument to use callback. First argument is your function. Second argument also is an array with the dependencies of this function. This function has no dependencies because set user ingredients is this special dependency since it's in the end returned by use state as this updating function by useState. So that's special, and other than that, we have no dependencies here, so we can specify an empty array here. By the way, you could have also passed setUserIngredients as a dependency here. It still wouldn't rerun because this never changes. That's guaranteed by React. That's why you can omit it here. You can also specify it. But this will now never rerun, and therefore what React does is it caches your function for you so that it survives re-render cycles, and therefore when this ingredients component re-renders, this specific function is not recreated, so it will not change. So what we pass to the search component to onload ingredients will be the old function, the same function as on the previous render cycle, and therefore in the search component, on the use effect here, on this check, onload ingredients will not have changed, and therefore this effect will not rerun. So now let's comment onload ingredients back in, and if we now save this, we see no infinite loop. Still one extra render cycle, to which I'll come back in a second, but if we have a look at the network tab, no extra requests sent. Only if I type here, we're sending extra requests with every keystroke. We see filtering is also working. For example, if I enter apples, we only see that. If I enter something which makes no sense, we see nothing. For bananas, we see bananas. That's working. We're sending a request with every keystroke, which might not be ideal. And we have an extra render cycle initially. So we should probably fix that. But we certainly have no infinite loop anymore. Before we ensure that we don't send a request with every keystroke, let's ensure we don't have this extra render cycle initially. And this is actually coming from a redundant HTTP request we're sending. If I open my developer tools and there the network tab, if I reload, I get a bunch of requests, but in the end you see there are two requests fetching our ingredients, these two requests. They're both sent to ingredients.json on Firebase. Now why do we have two requests being sent there? Well, because we send one in search.js, here in useEffect. When this component gets rendered, this effect executes. That's how effects work. They execute when this component gets rendered, because all these dependencies, of course, have changed compared to the previous render cycle, because there hasn't been a previous render cycle. So this gets recalled. And there, of course, entered filter is empty initially, so we have no filter set. Hence, we fetch all data, and then we call onload ingredients to, well, use these ingredients. And in addition to that, we're also fetching data in the ingredients component. There we also have useEffect, which we only execute once when the component loads, but we do that. And there we also fetch ingredients. Now, since we already are guaranteed to fetch ingredients because we're doing that in search, we of course don't need that extra useEffect thing here in the ingredients component. So we can get rid of that because we are fetching ingredients with search component. So with that, we're still loading it, but now we got rid of the extra render cycle. Now let's tackle the problem, kind of a problem I guess, that we're sending a request for every keystroke. We might not want to do that because we're spamming our server with requests if we do that. So would probably be better if we set some timer, and if the timer expired, we check if the current input in this, well, input here, is the same as at the beginning of the timer, and only if it's the same we know that there has been a pause and the user paused typing, and therefore we probably want to send a request. Now clear what I mean? Well, let me show you. Here is our effect, and in the end, here we're fetching data. Now at the beginning of the effect, I'll now actually use setTimeout, which is a normal JavaScript function, has nothing to do with hooks of course, to set a timer. And let's say the timer is 500 milliseconds, and you can use any value you want. Now I want to wait for the user to pause typing for 500 milliseconds, and only if that happened, I want to send a request. So in this anonymous function I'm passing here as a first argument to setTimeout, which is the function that executes after 500 milliseconds, there I want to send that request. So I'll move all that logic for constructing that query and sending that request into that setTimeout function. So that will happen after 500 milliseconds. Right now, of course, we're only deferring this, where we're not really doing anything else. Instead, we'll have to make sure that we also check after these 500 milliseconds, so inside of the function we pass the setTimeout, if entered value, entered filter, is the same as the entered value 500 milliseconds ago. Now, how can we do that? For that, it's important to understand how closures work in JavaScript. Entered filter here will actually be locked in when we set the timer. So it will not be the value the user has entered after this timer expired. it will be the value the user entered when we set this timer. That's important. That's how JavaScript works. So entered filter here will not be the current value the user entered. It will be the old value 500 milliseconds ago. Basically when useEffect executed and when we then set the timer therefore. So that's what entered filter will be. It will not be the current input, but the old one, so to say. Now, I also need the current one to compare what's currently in the input with what the user entered 500 milliseconds ago. And only if it's the same, I know, okay, it seems to be the value the user wants to go with. At least the user paused typing, so now is the time to send the HTTP request. So we need to compare it, but how do we get the current value? Well, we get that current value with something you also learned about in this course, with a reference. For that, React also has a hook, useRef. This allows us to create a reference simply by calling useRef, and you can store this in a constant, let's say the input ref, just like that. Now you can assign this to a DOM element by simply going to the element, in our case the input here, and there add the ref property, the ref prop, a special prop supported by React, and point at input ref. Now we established a connection between this input here, this input element, and the input ref variable or constant up here. We can now use this here and compare it. Input ref, current is the element. Current is a property the ref simply has, this ref object simply has. This will be an input element, therefore here we can check the value. If that value, and that will be the current value because input ref is defined outside of the closure, so that's not logged in or anything like that. So that's the current value currently entered in the input. If that's the same as the entered value when we set the timer, then we know the value hasn't changed in between, or at least it's now the same as it was at the beginning of the timer. So it's actually there, and hence I'll cut this one more time. It's actually there inside of this if statement, where we want to construct that query and send the request. Now, one important note here. Input ref, therefore now, of course, also is a dependency of our effect here, because I'm using input ref in the effect. And therefore, let's also add input ref here to make sure that we also rerun the effect if we should change what's stored in input ref. With that, let's save this. And now let me try typing, and that seems to work. I can filter, but we'll see something interesting if we have a look at the network tab. If I clear this, you see as I type, as long as I keep typing, no request is getting sent. Only if I make a short pause, a request is sent off. So if I type apples, it's only sent once I stop typing for 500 milliseconds. We'll have a problem though. Right now, we're not doing this in a perfect way. We're setting the timer, but keep in mind that we set a new timer whenever the effect runs, and the effect still runs in the end whenever our input changes. So we're setting a bunch of timers, which are all managed independently. That's not really what we want here. Instead of setting a timer for every effect, therefore having multiple timers in the end for every keystroke, we want to make sure we always clear the previous timer because it doesn't matter to us anymore. If there is a new keystroke, the old timer can be dismissed. We always just want to measure a change from the latest keystroke to, well, after the pause. We're not caring about an older keystroke. So we want to clean up that timer. The good thing is, set timeout in the end gives you a reference, a pointer at that timer, which we can store in a constant timer here. And I'm doing this in the function we're passing to useEffect. So this is the currently active timer. And now there's something on useEffect which I simply haven't shown you before. useEffect takes a function, and this function can actually return something. Let me shrink that if statement. It's still there, it's just shrunken so that we don't see it. After the if statement, and most importantly, after this timer, but still inside of that function we pass to useEffect. So at the end of this function, we can return something. And thus far, we haven't returned anything in useEffect. Now, you don't need to return anything, but you can return something. But when you do return something, it always has to be a function. And this is a cleanup function. It's a function that will run right before this same useEffect function will run the next time. So not after this function is done, but before the next time it will run. So on the first render, this executes and this does not execute. But then, on the first keystroke, we clean up the old effect, run a new one. On the second keystroke, we clean up that previous effect, run a new one, and so on. That's how this works. And here in the cleanup function, we can call clear timeout and pass in timer. This is how you clear a timer in JavaScript to clear that previous timer. Again, cleanup will run for the previous effect before the new effect is applied. So this cleans up the old timer before it sets a new one. And this ensures that we always only have one ongoing timer, which is of course better because we don't have all these redundant timers in memory. We have only one timer instead. So if I now save this, we won't see a strong difference here. Still the same behavior as before. Still works as before, but it's more memory efficient because we don't have all these old timers going on behind the scenes in memory. Instead, we only have one timer at a time, like this. So this is how this works. This is how we can work with that. And this is how you can clean up your effects, which you might need in situations like this, but also, for example, if you're setting up some subscription to a web service or anything like that, anything which might emit values regularly, you want to clean up your old subscription in that case, for example, if you're setting a new one with use effect. And here it's the same with the timer. We want to clear our old timer when we're setting a new one so that we don't have all these redundant timers in our memory, which ultimately will take up a lot of memory and make our app slower. So the filter is working. Let's go back to the ingredients component, which is where we, for example, add new ingredients. We also have a logic for removing ingredients, but right now we're not doing this in Firebase. We're only doing it locally, which of course means that, yeah, it's gone here, but if we reload, it's back. Now, to delete ingredients on the server as well, we of course need to send another request here. So let's copy that fetch request and move it in here into remove ingredient handler. There we send a delete request, which is understood by Firebase to delete data. You don't add a body here, don't need to add headers, but what you need to do is you need to specify in the URL which item you want to delete. Therefore, I'll use backticks here so that I can use string interpolation in that string, because now after ingredients, before .json, I'll add another segment, so another slash, and then string interpolation with $sign and curly braces. And here I'll simply add the ingredient ID. And that's a good thing. The ingredient ID is in the end what we get when we click on an item here anyways. In ingredients on Firebase, if we have a look, there in ingredients, ingredient IDs are the next nodes we have there. So we target one of these nodes with this delete request, and then this entry will simply be deleted. So that should be all we need. Here in the then block, we get the response. I don't really care about the response here though, but I only want to update my ingredients here in the UI once this response is there, which is why I moved that updating logic into this then block. Let's give it a try. All ingredients are there in Firebase. Let's click on apples. You see, it took a bit longer for them to be removed, but they're now also removed here. We only have bananas here. Therefore, if I reload, we of course only load the bananas. Obviously, I can re-add my apples, and they're back here as well. But now deleting works the way it should. But that's of course nothing too fancy or new. It's also not using React hooks. But what we can handle with hooks now is whenever we wait for something to complete, whenever we wait for data to be added or to be deleted, we could show a little loading spinner. And on the same hand, if we have an error, we might show that error modal, which I prepared. So that these are the next things we'll tackle. So let's make sure we show a loading spinner if we are, well, waiting for the HTTP request to complete. To do that, we of course need to manage an extra piece of state. Maybe isLoading and setIsLoading are appropriate names. With useState, and initially that's false. I need to manage state here because we'll change this, and every change should lead this ingredients component to re-render so that we can update our loading state and show something in the UI. Now, when we're adding an ingredient, let's say, then I want to set isLoading to true. We do this right before we call fetch. Once we got a response, however, I want to set it to false because now we're done. So I'm updating my state here with these calls to set is loading. This, of course, will also mean that we re-render the component. And now we can use our loading indicator to, well, output whether we're loading or not. We could display this indicator in all kinds of places. I like to display it in my ingredient form, but it's up to you. I will add a loading prop here and point at is loading here. So forward the is loading state to the ingredient form. And in the ingredient form, there we can import the loading indicator from UI loading indicator. So that's a component I prepared for you. It's a little spinner. And then down there, next to the button, we can check props loading. And if that's true, then I want to render the loading indicator. Otherwise, I want to return nothing. By the way, a shortcut for this is that you replace the question mark with and, so with 2 ampersand signs, and then you omit this colon else case, and now this means this will only get rendered if this is true. It's a little JavaScript syntax where this is checked, and if this is true, this gets rendered, or this gets returned, and in this case, since we're in React, this gets rendered. So now if loading is true, we should see an indicator. We're setting loading when we add ingredients. Let's also do it when we remove ingredients. There I call set is loading, set it to true initially, and only once it is deleted, so here in the then block, I'll set it to false because we're not loading anymore. So if we save this, now if we add chocolate 1, we should see a loading spinner here, and we do. And if I now delete something, we also see one. So that's a bit better. And of course, we could do something similar when we're loading all ingredients initially. We'll take care about this later. For now, this is what I wanted to show you though. Let's next handle errors. Things also could go wrong. Let's say for removing, we get an error. And Firebase, unfortunately, kind of is really stable, so we probably won't get an error there. But if I remove the S here in JSON, we'll force a technical error. Therefore, now if I click on chocolate, actually this keeps on spinning, this doesn't get removed, and here we see we have an erroneous request. We got an error, but we're not handling it. And that's not a great user experience because it's not obvious to the user who hasn't the developer tools open what went wrong. So we want to handle errors like this. Now with fetch, since it returns a promise, we can handle errors by adding catch here. And catch will get the error and then allows us to do whatever we want with that error. Now here, I want to output my error modal and show a nice error message if something goes wrong. Therefore, I'll import the error modal from the UI folder and their error modal.js and render this if we have an error. Hence, we need to manage an extra piece of state. Error and set error with use state. And initially, I pass no value in there because we have no error. Initially, it's just undefined or null initially. But now we can call set error whenever we got an error. So let's say, because here I know that we'll have one, in the remove ingredient handler, in the catch block here, we call set error, and I set error.message as a value. Every error object by default has a message property. So I'm setting this message as a field or as a value for error. And you can, of course, manage whatever you want in here. You can also set your own message, like something went wrong, anything like that. And I'll do that here because the predefined message might be really cryptic to users, so I showed this one. Now we can output the error modal if error is set. So if that error state is set. For this here, in this div, I want to check if error is true. Remember, error is my error state. So if error is true, and if it is, using the same shortcut as before, I'll render the error modal. So this only gets rendered if error is set. And then to the error modal, I pass my error message, and that's just what I store in error. Now, error modal actually is a component which tries to call on close if we click the backdrop or the OK button. So I'll add on close here, and there I want to execute a function that clears the error. So I'll add a new function, clear error, or whatever you want to name it. And in the end, what this does is it calls set error and sets this back to null. And if that is null, this error modal will also disappear because this condition will not be satisfied anymore. Null is treated as false and therefore this won't get rendered. So here on close, I will point at clear error. So at this function, which should get executed if on close is triggered. In addition to setting the error here, I also want to set is loading to false here. Because even with the error, we are not loading anymore, so the loading spinner here should disappear. Otherwise, that will keep on going. Now, if we save this, and I click on that, I get that error modal. If I click OK, we're done. That's also another important thing you have to understand regarding how React works. React also batches state updates. I'm naming it set state here because whenever you call a set whatever it is, function from use state, this will of course trigger a state update. And there React has a mechanism for batching multiple updates together to avoid unnecessary render cycles. So when you set your new state, no matter which approach you use, React batches these state updates. So that also means that right in the next line after calling set new state, you can't immediately use the new state because React won't go ahead and update the state and skip all the other code. Instead, it will execute all the other code in the same function and batch all state updates you scheduled there together. So all state updates from one and the same synchronous event handler, that's important, synchronous, are batched together. That's a bit theoretic. What does this mean? It means that here in clear error, for example, I have set error and set is loading. This is in the same function. These two steps are executed synchronously after each other. So even if that were in a then block, if both are in the same then block, then these two always run right after each other, and then React batches these two state updates together. So this will not mean that set error causes a re-render cycle and set is loading causes another one, but we'll only have one render cycle here, which updates both states, or which reflects both state updates to be precise. And looking at that, set is loading is actually wrong here in clear error, or not wrong, but you might also argue that you want to move it here where you set the error initially, then this spinning icon also disappears right when the modal opens, of course, because we're setting loading at the same point of time we're setting the error. But these two again will be batched together, so it's not two render cycles that are executed to show the error modal and to remove the spinner, but it's one and the same render cycle which already has both state updates taken into account. So that's how React batches state updates and how you can handle error with a separate state, of course, where you store errors and then react to them appropriately. Now, in a scenario like this, we have three different states we're managing, and they're all kind of related, if you're honest. They're all related to us interacting with an HTTP request. Our user ingredients change whenever we send a request because we either loaded data or we deleted data or we added data. And we're waiting for this request to be done right before we change user ingredients, or we might also have an error. So these three states are actually closely related. We're managing them kind of independently, but also we sometimes update two at the same time. Like here, where we set error and set is loading right after each other. Thanks to React's batching mechanism, that's no problem, it works just fine. But still, it might be a bit annoying to manage these states independently. By the way, that would get worse if one of the states would depend on another state, which arguably kind of is the case already. When we set our ingredients because we added a new one, we're depending on our old ingredients. It's not really a different state. We're not depending on loading or error here, but it's an older snapshot of the same state. So in such cases where you depend on the older state, or you need to update new state based on maybe also some other new state of another state object, then there is a better way than using use state. You can instead call or use reducer, another built-in hook. Now, if you followed through the Redux section, the word reducer already tells you something. Reducers are functions that take some input and return some output in the end. And use reducer uses that to give you a clearly defined way of defining state changes and state updates, and it will then also manage that state for you. So React will do that. It all starts with you defining a reducer, and you typically do that outside of your component so that this reducer function isn't recreated whenever the component re-renders, because the reducer function often is decoupled from what's happening inside your component actually. So here we can have our ingredient reducer, let's say, and we'll actually build two reducers, by the way, but let's start with the ingredient reducer. And this in the end stores a function. This function will automatically get two arguments passed in by React. The state, and you could name it state, but I'll name it current ingredients. So the ingredients currently stored by React, and an action. That action will become important for updating the state. Now, you also know that concept of actions if you watch the Redux section. An action is an object which could have a type, and then we can use a switch statement to define different cases for different code we want to execute for different types of actions we're getting. For example, we could have a case to set our ingredients. We could have another case for adding an ingredient, and we could have a third case for deleting an ingredient. Now, these are all just identifiers I came up with. You can use any identifier you want. You typically also should have a default case here, but we should never reach this, so here I'll just throw a new error. Should not get there, because we should actually handle all cases that we can have. Now, a reducer, as I said, needs to return something, and will return different things for all these cases. Here we throw an error, which also cancels this function. Here we're not returning an error, but we return something new, and that should be our new ingredients. Now, if we call set, then I want to override my current ingredients with a new list, a new array of ingredients, and that should be part of the action object I'm getting. So there I expect to get an ingredients property, which should be an array of ingredients which will replace the old state. Now, in the add case here, we also want to return a new state snapshot. And our state here is an array, right? Because ingredients is an array, so we should return an array. But here, of course, it should be our old array plus the new item. So the logic is the same as we have it in our add ingredient handler in the end. There we copy our old ingredients, then we add a new one. So here in add, I copy my old ones, which are the current ingredients here, which I get automatically. And then we add a new item, and that has to be part of the action we're getting. And now it's up to you whether you expect to get that all already merged into one object on the action, like ingredient, or if you got 3 different properties. You will be the one dispatching these actions later, so you can decide which data is in there. And here I expect to get my ingredient in the action. Now, in the delete case here, we need to return our updated list of ingredients. So I'll take my current ingredients and then again use filter, run some logic on every ingredient and compare the ingredient ID with, let's say, the action ID. So I expect to have an ID field on the incoming action, which is the ID of the ingredient that should be deleted. And therefore, all ingredients where this is not equal should be kept. The one where it is equal will be dropped from the new list. And the new list is returned. What we return here replaces the old state. So that's our reducer, the reducer function. That alone doesn't do much. We now need to initialize it by calling useReducer, or utilize it by calling useReducer. UseReducer takes our reducer function, so the ingredient reducer in this case here, and useReducer also takes an optional sect argument, which is the starting state. And in our case, that's an empty array. So that's what will be passed in as current ingredients the first time this reducer runs. And for subsequent runs, current ingredients will be our current state. Initially, it's an empty array. And useReducer, like useState, returns something. That something also is an array, but now not with state and set state, but with state, so our user ingredients. So we can comment out this use state call here, user ingredients. But the second argument is now not a method to set our user ingredients. Instead, we're doing the setting in our reducer. Instead, it's a dispatch function. It's still a function which we can call, and you can name this whatever you want. The name dispatch is just one that makes sense because it's a function which you'll call to dispatch these actions later. So where you dispatch these action objects, which are then handled by the reducer. So I'll temporarily, again, still import use state so that the other code still works. But let's now utilize dispatch in the places where we previously called set user ingredients. Because we can't use that anymore, we're not managing the user ingredients with use state. Instead, here we now dispatch for setting the ingredients. And now here you need to dispatch an action. The action could be anything, could be a string, but typically it's an object. And here it's an object where we want to have a type property describing what action we want to do. And then maybe, depending on which action we're running, some extra data, like for setting our ingredients property here. So here I'll dispatch an object with a type property. Type is set here. And of course, this has to be one of the identifiers you're handling in the reducer. So here it's the set identifier. And then this set action needs an ingredients property to work correctly. So here I add ingredients and set this equal to the filtered ingredients I'm getting. And with that, we're using dispatch to update our user ingredients. Hence now already, if we save this, this would work. But of course, we got two other places where we previously called set user ingredients. Like here, where we add an ingredient. We now instead call dispatch an action object where the type is add. Again, that's the identifier we're using in the reducer. And there we expect to get an ingredient property. So I'll add ingredient here. An ingredient is constructed as I'm constructing it here. So it's an object with my ID, and with the ingredient data I am getting here as an input to this function. So now we dispatch this. And finally, for deleting, instead of running this code, we also dispatch an action where the type is delete. Again, because we have the delete type here. And there I expect to get an ID field in the action object. You could have multiple fields. You don't always have to just have type and one other field. You can have as many fields in here as you want. Here, however, it will be the ID. And that will simply be the ingredient ID I'm getting here as an input to my remove ingredient handler. So that's now forwarded. With that, if we save this, this works. Our data loads. And if I add, for example, apples, that works. And to show that deleting also works, I'll fix that error in my delete HTTP request by adding that S again in JSON. And now if I click on, let's say, chocolate, this is removed and it stays away if we reload. So that's how we can use reducer. Now here I added use reducer instead of use state, not because we replaced so many state things with it. Actually, we only replaced this one user ingredient state. But because we have multiple ways of changing that state, and some of these ways depend on the previous state. And whilst the previous approach there, of course, also worked fine, using a reducer often is cleaner, because you have all your updating logic in one place, in the reducer, and then you just dispatch these actions, which is a very clear and easy to understand flow for how you manage your data. So whenever you have more complex state that can change in different ways, instead of just, let's say, setting a Boolean from true to false, but like here where we can add ingredients or remove ingredients, whenever you have such a state that is a bit more complex and that might also depend on previous state, then you should strongly consider using a reducer to have a cleaner logic, to have all in one place, basically. And ultimately, it's of course up to your personal preference, though. Another scenario where using use reducer could make sense is if you have multiple connected states. Like here, is loading an error? They're both related to us sending HTTP requests, and whilst we manage them independently, they're kind of related. Now you can of course manage it like this, but also here, often a reducer makes your code easier to reason about, easier to understand. So I'll add another reducer, again, outside of my component. Doesn't have to be outside. You could move it in there, for example, if you use props in your reducer, but if you don't need to, put it outside of the component to avoid unnecessary recreations of the reducer. So here, I'll name this HTTP reducer maybe. Again, get my HTTP state and my action. And just as before, you can name these arguments whatever you want, of course, but this will be your old state basically, and that's the action you're getting. And just as before, we can switch the action type because there will be different actions we'll dispatch. And now let's think about which actions might we have when we work with HTTP requests. Well, if we have a look at our code, then we always start by sending the request, right? We start off by sending a request. So sending a request probably is one action. Another action we then have is when the response is there, in this then case, or when we have an error, in this catch case. So we have three possible states here that make sense. Three different cases, I should say. So the first case is send, or send request, or whatever you want to name it. I'll just name it send. The second case is response. So the response is there. Again, you can name this whatever you want. And an error case. And just as before, a default case where I, however, will only throw a new error. Should not be reached. Because we're the ones dispatching these actions, we should of course make sure we only dispatch actions with these identifiers. If we ever see this error, then we dispatched some action we're not handling. And then we should either fix a typo we have or add a case for that action. Now what happens if we send a request? Now it's important to understand that here we'll not send the request itself. We're doing that down there. Here I just want to manage the state that is related to that request being sent that influences our UI. So the state there is basically whether we show a loading spinner or whether we show an error. That's essentially the state I want to manage related to that request. So here, when we initialize this with use reducer and we point at our HTTP reducer, then the initial state could be an object where we have two fields, and that is loading, which is false initially, and error, which is null initially. Here I'm using an object because a reducer could also just manage a single string, but here I want to have multiple connected fields, and therefore I have an object to connect them. Now when we send a request, we want to set loading to true, and the error probably to null, because we have no error yet if we just send the request. And this is the new state we'll return. Of course, it should match the signature of our general state, like the initial state we're managing here. And that is the case here. We have a loading property and we have an error property. If we got a response, then I'll set loading to false and I'll set error to null, or actually I just don't want to change the error. A common pattern therefore is that you actually set the property you want to set, but before you do that, you simply take your existing state and use the spread operator to pull all key value pairs out of it, merge it with this new object, which will be returned as your new state, so that you don't lose anything from the old state. And whatever you set thereafter will override any properties of the same name that were pulled out of the old state. So if the old state, we have a loading property in there, we're pulling that out and adding it to the object, but since we also define it here, we then override that value with that new value. Other properties, which we don't override here, will simply be kept in this new object. If we have an error, then I want to set loading to false, because we're still not loading anymore, even if we have an error, and set the error to action error. So we probably should get it here, or error data, or whatever you want to have here. You're the one writing the code, you can define what you expect on your actions. Here I'm not using the spread trick or the spread approach, because here I'm setting both properties which my state here has. So no need to spread existing properties. I would overwrite all of them anyways. So that's the HTTP reducer. Use reducer therefore returns our HTTP state, or whatever you want to name it. I'll name it HTTP state. It's the same name as I have up there. So to avoid confusion, you don't have to change any of the two because they're in different scopes. But to avoid confusion, I'll name this priv HTTP or cur HTTP state, because it's the current state before the update up there, and here it's just HTTP state. And again, we get dispatch. Now I already have a dispatch variable though, so I'll rename this to dispatch HTTP so that we have no name clash here. And here we need to rename it because they're in the same scope, hence we can't use the same name twice. So now we can get rid of these two use state statements and now fix all these errors we're getting. For example, here for loading. In the end, what's happening here is that I want to dispatch an HTTP action, and that action is of type send. So that's the identifier I defined here. And that will then automatically set these state values. We don't need to pass any extra data to that action because that action doesn't need any external data to work. So we send a request here. Now, when we got a response, I'll send the response request here. Down there in remove ingredient handler, again, it's the send request which I'm sending. And then here, if we got a response, it's the response request. Only here, if we have an error, well, then I want to dispatch my error action. And that's the only action here that then takes an extra argument, because in our reducer, we're accessing error data on the action to get the error. Actually, I'll rename this to error message because I want to get the message and store that in error, so that error always is a message. And then down there, I pass error message as a key, and that is error.message, or again, a message of your choice, like something went wrong. Now in clear error, there we actually need to dispatch an action we don't have yet. So let's register a new case, and that is clear maybe, where I return my current HTTP state, but I set error to null, because that's what we're doing here. We're keeping all the old state in this new state object we're returning, but we're setting error to null. So now we can dispatch this clear action here. So dispatch HTTP with an object where the type is set to clear, so that this clearing is happening. Well, and then here, instead of error, we access HTTP state. Remember that HTTP state is now what we're extracting from the result of use reducer here. So that is in the end this object with loading and error, which we're constantly updating. So we got our HTTP state, which might contain an error. HTTP state error is what I output here, and HTTP state error also is what we need to check here. And then here it's HTTP state loading. With that, if we save this should again work correctly. If I add a new item here, we see the spinner, so loading works, we see that here. And now if we add an error again, for removing, let's say, by again removing that S from JSON, if I now click here, we see that, we see the error modal, we can close it. So that is now all working. Let me re-add the S. With that, we're using a reducer for this too. Here, we're doing it because we have multiple connected pieces of state, which we now can manage in one place and still make sure that we always get the old state, that we update everything correctly, and that again, we take some logic out of our component here and move it into the reducer functions so that we have cleaner code where we have a clearly defined flow of data and of where we change our data. Now we can also get rid of the use state import here in the ingredients.js file, because now we're managing all our state with use reducer, which is an alternative to use state if you got more complex state that relies on the old state, or if multiple state values work together and you want to manage them in one place and update them correctly. Now that we had a thorough look at use state, use effect, use reducer, we also used use callback, let's have a look at how we can use the context API, which is also an exciting feature about React, together with functional components and hooks. And for that, I got my auth.js file, which we haven't used thus far, which is a very simple login form. Well, it doesn't even have inputs, but it has a login button at least, which we can click. And I want to show that if we're not logged in yet, and alternatively show my ingredients if we are logged in. That's where the app.js file will come into play. Right now, it always returns ingredients. The goal is that now this does not always return ingredients, but instead it returns either ingredients or the auth screen. So here in app.js, I'll import auth from ./components auth. And well, we could now always return auth, of course, which means we would always see this. But now we got no way of, going to our ingredients. So the goal will be that we switch between those. Now, of course, for that, we can manage all the auth logic here in app use an if statement to render different content. We could do that. But in a more complex app, of course, you might be interested in whether the user is authenticated or not in a couple of components, maybe deeply nested into other components. And therefore, passing data about the authentication status via props might not be what you want to do, because you build very long chains of props which you have to pass around. That's where context can help us. For that, I'll create a new folder, context, which is optional, but I like to store my context in there, and name this auth-context.js. This is the file name in there. Now in this auth-context file, we can create context by importing React from React. And then we create our, let's say, auth-context. Name is totally up to you, but should start with a capital character actually, by calling React create context. And this is also something I covered earlier in the course already. This is the context API offered by React. So go back to that component deep dive section if you're not entirely sure what this means. Now we can initialize this with a value, and there I want to manage whether we're authenticated or not. And I want to provide a login function, which here is just an empty function, but which I still add here to get better auto-completion. We'll override this with a concrete value soon. I will also export this context object, but I will also use it in that same file to create a component there. I'll name the component auth-context-provider. It's a normal React component, a functional component as you can tell. And in there I return auth-context.provider. So I'm using auth-context up there, and this automatically is a valid React component, or at least with .provider, it gives you a valid React component. And between there, I want to allow anything. So I'll add props children there, so that we can use the auth-context provider, pass anything as a child to it, and it will be wrapped by our context. Now it's in here where I want to manage that login status, and I'll do this with the help of useState now. useState because it's a really simple state. It's a simple state because I only want to track whether the user is authenticated, and I want to be able to set is authenticated or not. And initially the user is not authenticated, which is why I initialize this with a false value. Now I'll also add a function here, log user in, or whatever you want to name it, or login handler. Name is totally up to you. This takes no arguments here because it's just about showing how to work with context, not about really taking inputs here and validating that. And then I'll call set is authenticated and set this to true. That's what I do here. Very trivial function. Now the auth-context provider gets a value which will automatically be distributed to everyone listening if it changes, which describes our context. Initially we have this starting value, but now I will immediately override it with a new object where I have login. And that's my login handler pointing at this function. So now we have a real function behind it. And is auth, where we have is authenticated, so this state value. And again, if this changes, so for example, if we call set is authenticated, everyone listening will get this updated value. So now we just need to export, maybe as a default, this auth-context provider, so this component which we built here. And now I have this default export, and here we have a named export. And now we can use that, and we can use it in the index.js file, so the root of our application. There we can import the auth-context provider from .context, ./context, auth-context, and wrap our entire app with it. So wrap the entire app with auth-context provider like this, so that the entire app receives our context, or is able to receive it. You can listen to the context from everywhere in the app. That's the right way of putting it. So auth-context provider is wrapped around our app. In app.js, I'm already interested in it. And that's the thing which could be problematic with functional props. We can, of course, import our auth-context, so not the provider component, but the context object itself, from ./context auth-context. However, here I mean the named export, so we have to wrap this in curly braces. And what we can do is we can wrap this here with auth-context.consumer now to set up this render function in the end in there. This would be how you can use context in functional components. This means that if you need data from the context anywhere else but in your JSX tree, you have no way of getting it. You would need to transform this into a class-based component so that you can add the static context type thing, which you might remember from earlier in the course. Well, thankfully, there is a hook to also fix this. The useContext hook, you use it like this. You pass in the context you want to listen to, so to say, of context in my case, and you get a handle to that context, which is then stored in this constant. And you can name it whatever you want. Here I name it of context. And now here in app.js, I can listen to of context.isOf, or not listen to it, but check it, and this will be rebuilt whenever the context changes, whenever the value in there changes. So whenever we change isOf, for example, then this will rebuild. So here I listen to it, and then I want to output a different content. Let's say my default content here is the of component, like this. But if we are authenticated, then content, of course, is the ingredients component. And then down there, instead of hard coding context, I return content, which is changed depending on the value in context. Now we just need to make sure that clicking on the login button also does reach the, well, login handler function here. Keep in mind that a pointer at this function is stored in login in the context. So all I have to do is I have to go to the place where the button is, which is in the of component, and also import the of context there, of context, the named import, from the context folder of-context, and import the use context hook here as well. And now here, I can get access to my of context with use context pointing at of context. And in the login handler, I'll call of context.login as a function. And now with that, if we click that button, we're logged in and we see the ingredients. So this is how we can work with context with functional components and the use context hook. Now that we had a look at so many different hooks, let's take a step back, or actually stay in the hooks world, but see how we can optimize our project, how we can avoid unnecessary re-render cycles, because that's of course something we might also be interested in doing to ensure that we have an app that performs well. And for that, let's have a look at the ingredients.js file. There we're managing a bunch of logic. We have two reducers in there. We're changing the loading state, for example, and we update the UI in this case. And one thing I can already see there is that, for example, I'm passing the add ingredient handler to the ingredient form, and add ingredient handler in the end is just this function. This means that since it's a function defined inside of this functional component, whenever this functional component rebuilds and therefore this whole function gets executed again, this function will be recreated. Now, a side note here, by the way, use reducer and so on will not be recreated. Of course, this is called again, but React detects that this reducer is already initialized for this component and uses that already initialized value. So that's no problem. But here for add ingredient handler and so on, we're creating a brand new function. This brand new function is therefore passed down to the ingredient form. And hence in the ingredient form, even though I'm using React Memo, this will rebuild. And I can prove this to you. Can throw in a console log rendering ingredient form, and theoretically that should only be rendered whenever we type in there, because these are the only things that change the form, and of course when we initially load it. But what you will see is that, for example, if I add something, test 5, let's clear the log, I hit add ingredient, you see it's re-rendered a bunch, and that makes sense because it's re-rendered when we change the loading state. Well, actually that makes sense because we're outputting the loading indicator here. But it's also re-rendered once the data is there and we're outputting the data down there. And this is not what we want. There is no reason to render this form if we're just outputting some data down there. So that should be one render cycle too much we have here. 2 makes sense because we switch loading from false to true and then back from true to false once we're done. So we definitely will render twice because the loading spinner is in the form. But the third output here makes no sense. We can get rid of that by wrapping add ingredient handler with use callback, which we already saw before. And for that, you need to import use callback from React, of course. And then you wrap your entire handler function with that. And then you add square brackets where you define the dependencies of this function. The dependency here is dispatch HTTP, which you don't need to specify because just like the updating function from use state, this is guaranteed by React to not change between render cycles. So you could add it, but you don't have to. Ingredient is a local argument we're getting in the function, not an external one, so nothing we need to do there. And therefore, overall, there's nothing in here on which this would depend. So this function actually should never be rebuilt. It's always the same function. It has no external dependencies other than dispatch HTTP, which, as I said, is managed by React such that it won't change. So it's not really a dependency. If we do that, then if we log in here and I add another ingredient here, we only see 2 render cycles. The third one is gone because this function, add ingredient handler, is now not rebuilt. We're passing this function into ingredient form, but since it doesn't change between render cycles, React Memo detects that the new function we're getting when the parent component rebuilds is the old function and therefore doesn't rebuild this component. That's how it works. Loading, when it changes, of course, breaks through that, as it should, and triggers a rebuild on the ingredient form if it changes. If loading would not change, if we had false before and false for the next render cycle as well, this would not be rebuilt. So now we're taking advantage of React Memo here. The same for the ingredient list. When we change the ingredients, this should rebuild, but it will now also rebuild all the time because we pass in the remove ingredient handler, and that's also not wrapped by use callback. The result of that is that the ingredient list will also rebuild too often. If we add a console log statement in there, rendering ingredient list, something like this, then you'll see, of course, it loads initially a couple of times because of the loading state change. It loads initially and then loads once the data is there. But you will also see that it also loads in cases where it shouldn't. For example, if I click on test here, it renders way too often. Of course it should render once the data is gone, but it should not render just because we're showing a loading spinner up there, and that is the first thing we're doing. So, same logic as before. The dependencies of ingredient list are on remove item. Please note I'm not using React Memo here, so the following change will not alone have a result. But still it's a first step. Remove ingredient handler, we use callback here, and wrap this entire function with it, and then specify the dependencies. Dependencies are dispatch HTTP, which, as mentioned, doesn't have to be specified. Ingredient ID is an internal value, not an external one. Nothing else in there which matters, so it's an empty array. Now again, as mentioned, this alone won't make a difference. If I delete test here, we still see a bunch of ingredient list re-renderings. Now, it makes sense because in ingredient list, I'm not using React Memo. So of course, we can do this. We can use React Memo here, wrap this entire component with it, like this. And if we do so, we log in, clear this, and I click bananas, we only render it once. So we're having the effect we want. We're only rendering this when this changes, not when something totally different changes. And there's nothing wrong with doing this, and actually this is the approach you'll typically use. Still, I want to show you an alternative, because there also is another hook you can use, and that's the use memo hook. Use callback was a hook to save a function that doesn't change so that no new function is generated. Use memo is a hook where you can save a value which is saved so that the value isn't recreated. And that is another way of memorizing a component. So here, that would be our ingredient list. Let me cut it from there and add it here. Ingredient list maybe like this. And now use memo here. Pass a function to it. This is not a function that's now memorized though. Instead, it's a function that React will execute for you. And that function should return the value which you want to memorize. Ingredient list here. Now use memo also needs a second argument, which is a list of dependencies you have. This tells React when it should rerun this function to create a new object that it should memorize. And we know it should rerun this function whenever the user ingredients change. So let's add this here. Or whenever remove ingredient handler changes. And that shouldn't change because we wrapped that with use callback. So only changes to user ingredients should really rerun this function and rebuild a new ingredient list. And now ingredient list is of course something we can output down there. Ingredient list like this. If we save this and we log in, ingredients are getting rendered. Now let's add bananas here. 10. Add this. We updated the ingredient list once. If I delete them, we updated it once. It's an alternative to React Memo. Now, if we're talking about storing components, you typically want to use React Memo instead of use memo. But keep in mind that with use memo, you can store any data which you don't want to recreate on every re-render cycle of this component. So if you have some operation that calculates a more complex value, calculates a value which maybe takes a bit longer to calculate, then you want to consider wrapping it with use memo so that it's not recalculated whenever the component re-renders, but really only recalculated when you need to recalculate it. That's the idea here. Now, last optimization I want to apply is here on the error modal. On close, we call clear error. It's this function. And there again, we can use callback to make sure that the error modal isn't re-rendered unnecessarily. We have no external dependencies here, so it's as simple as that. And now we also make sure that the error modal, which already uses React Memo, isn't re-rendered in cases where it shouldn't. So these are some optimizations you can apply and you should think about. Now, it's not the end of the world if you forget one, because re-rendering sounds like a super intensive work. If it's a small component, an easy update, it might be super fast to re-render. And re-render always means re-rendered in the virtual DOM, right? You learned that earlier in the course. Does not mean that whatever changed is automatically written to the real DOM. But even that virtual DOM re-rendering can be avoided with use callback, use memo, and React Memo. But if you have very trivial components, it might even be worth not adding React Memo, so you shouldn't wrap every component with React Memo or with use memo, because React then always needs to check whether props changed, and if it's a super small component, re-rendering it might just be faster than performing that check. So it's always something you have to evaluate and think about. For example, for the error modal, we could probably get away with always re-rendering that and not using React Memo. So these are examples, and these are things you just have to play around with, test, and also check how fast your application is to get a feeling for this, where it makes sense and where it doesn't make sense. So we're almost done with this module, but one very cool feature is missing, and that is custom hooks. You can build your own hooks. You're not restricted to the built-in ones. So let's do that. I'll add a new hooks folder where I want to store my hooks, and there I'll add one custom hook, and that's my HTTP hook. Because I have that HTTP functionality in Ingredients.js, for example, where I send HTTP requests. I do this multiple times, and the pattern always is the same. Dispatch send at the beginning, dispatch response once the response is there, dispatch error if we have an error. It's always the same pattern. So we have logic that we want to share across components, but, and that's the important thing, logic which also influences the state of the components where we want to use that logic. So we can't use a normal function, because of course we could build our normal send request function, which simply has all that send request logic in there, but from in a normal function, we couldn't dispatch events which then change the state in a component that calls the function. That's something only hooks can do. And that's why we build our own hook now. So in the HTTP.js file, in the hooks folder, I want to build my own hook. And the first very important thing there is your own hooks should always be named use something. In my case here, use HTTP or use fetch or whatever you want to name it, but use something written like this. And I'll go with use HTTP. Then your hook is just a function. It's a normal JavaScript function, just treated in a special way by React. That's the core thing. So now we have this, and I will export use HTTP here. So that's a very simple hook, which doesn't do anything, but it's a start. The cool thing is, in this hook, you can now use stateful features. You can use state, use effect, use reducer, anything. You can use any hook in there. And any component that uses your own hook will then run this hook as if you had the code written in here directly in the component. So it's not like you have one function shared by multiple components and then they run the same code with the same data. No, each functional component gets its own snapshot of this hook, so to say. So that's a cool thing. You can have stateful logic in there, but the stateful logic will then be different for each component where you use that hook, so that you can share the logic, not the data. That's the idea behind hooks. So what do we want to have in this custom hook? Well, I'd say it makes sense to move our HTTP reducer into there. So let's go to ingredients.js and fetch this HTTP reducer, cut it from there, and let me close the UI folder, move it here into HTTP.js. And I'll define it outside of the hook, because again, this doesn't need to rerun with every re-render cycle, and your hook will rerun with every re-render cycle. That's important. Your hook will get called whenever the component where you're using your hook gets re-executed. And then you can use techniques in your hook, of course, to make sure that nothing happens to the state or that something does happen, depending on what you want. But in general, it will get re-executed. I don't want to recreate the reducer all of the time, so I'll move that out of there, just as we did it for the component. Now, of course, since the reducer function was removed, I'll also remove the useReducer call from ingredients.js and move it into HTTP.js, now inside of my custom hook, here. Now to use useReducer, we have to import it. So let's import useReducer from React. We don't need to import React itself here because we're not building a React component here. We just want to use some features from the React package, in this case, useReducer. So here I then have my state and dispatch HTTP, which right now isn't that useful, but we'll get there. Now the request itself. Let's go to ingredients.js and let's grab one of these requests. Let's grab the one where we handle the error here in remove ingredient. I'll take this entire fetch block with all the then and catch blocks thereafter, cut it, and add it to HTTP.js. This would now execute this HTTP request whenever the component that uses useHTTP reruns. And that's certainly not what we want here. We don't want to run this all the time. Instead, I'll create a new function here in my useHTTP hook, which I'll name sendRequest. Name is up to you though. And that is a function which should actually send the request, so that it's not always getting sent when useHTTP is called, but only when sendRequest is called, which right now never happens, but we'll do that soon. Now, sendRequest, of course, needs to be a bit more flexible because we don't always want to send the request to this URL here. So the URL should probably be something we get from outside. The same for the method and the body of the request. So here I'll remove the URL and use the URL argument instead. And for method, I'll use method. And we might have a body, which is the body we're getting. And because it doesn't hurt here, I'll always add the header content type application JSON. For a GET request, we don't need it, but it won't hurt. And for some requests, like POST requests, we need it. So we'll always append it. Now we have a flexible HTTP request, a fetch call, which depends on data we get from outside, which will go ahead and then dispatch our response. And at the beginning, also dispatch an action of type send. So that's the statefulness I was talking about. We're interacting with our reducer here because this custom hook will in the end be used in a component which then will automatically get all that state, so to say, or where this state will be connected to by React automatically. So here we send, here we get the response. Now, of course, what we do with the response, however, in this case that we delete the ingredient, that doesn't belong to this hook. That's something the component that uses our hook needs to do. The hook should be just caring about the HTTP request, not about what we do with the response. So we'll have to see how we manage that. For the error, I dispatch this error request. But how can we now get the response data back to, well, the component that uses our own request? Well, we can add something new to our HTTP state here. Let's start with the initial state. Besides loading an error, we can have some data in there, which initially is null. But if we get a response, besides setting loading to false, I set data, equal to action.response data, for example, a key I'm expecting on the action. When we send a request, I'll reset data to null here, so that this is definitely null once we send a new request. So I get response data if we have a response. So here, when we have a response, I'll actually cut this and return response JSON, which extracts us the response body. And then the next block, I got my response data extracted. And in here, I dispatch the response action. But now we edited this action, or this case here, to also extract response data from the action. So we'll set a response data key on the action we're dispatching and save my response data we're getting here, thanks to response JSON, in there, so that it's now part of the action. So now the important thing is, the data we're getting for the request we're sending is stored in our state here. That's all nice, but still, it's in the hook. How do we now connect this to our component? Well, just like some of the built-in hooks, our own hook can, of course, return something. So here, at the end of the hook, I will return an array, but you don't have to return an array. You can also return an object here, or a single number, whatever your hook needs. Here, I'll go with an array, or actually, I'll go with an object to show that you can return different things than just arrays. And in that object, I'll return my isLoading key, and that is coming from HTTP state, which is what useReducer returns me here, which I'm extracting here, which will have a loading property, an error property, and a data property. So here it's HTTP state loading. Then we have data, which is HTTP state data, and we have an error, which is HTTP state error. So this is what my hook now returns, and now we can use that hook. In ingredients.js, there, let's import use HTTP, and here you also have to, you can name it whatever you want, but it has to start with use from hooks HTTP, like that. So now I want to use HTTP, and just as all other hooks, you have to use it on the root level. So we can't use it in here in the remove ingredient handler. That won't work. Instead, we have to call use HTTP somewhere here, like that. But that's okay, because use HTTP doesn't send the request actually. It just sets up the logic for sending a request. It sets up our state, and it sets up this function which sends a request. So we should probably return that function too. So in this object I'm returning, I'm also returning send request, and I point at this send request function. So now we return a handle to this function as well. Now, to avoid unnecessary re-renders, I'll already also import use callback here and wrap send request with use callback like this, and add an empty array as a second argument, because this doesn't have any external dependencies. So it's good like that. So send request is returned, and it will not re-render unnecessarily, which helps us optimize rebuilds. And now in ingredients.js, use HTTP therefore returns our HTTP object, whatever you want to call it. In the end, that's our object where we can use destructuring to pull out isLoading, a potential error we're getting, the data we're getting, and send request. These are the four things, the four properties we're returning in our hook. These four properties. And with object destructuring, which I'm using here, I'm pulling them out and storing them in separate constants. Now we can use these constants. So for the moment, I'll comment all of that logic here out. We'll fix that later. And here, where we use HTTP state error in our JSX code, I just use error, because that's one of the things I pulled out of my result from use state. And for loading, well, it's just isLoading, another thing I'm pulling out from there. Now, when we're deleting an ingredient here, I therefore in the end just use send request to send a request to a URL. And that should be, of course, the URL of an ingredient. So it's this URL. So let's use backticks here actually, so that we can inject values. Then it's /ingredients at the end. Then, just as before, the ingredient ID, and then .json. That's the URL. Then the method is delete. That's the second argument send request expects. And we need no body, so we can omit the third argument. Now, send request is now a dependency of use callback because send request is actually a thing we're returning here from use HTTP. And if we would not wrap send request with use callback inside of use HTTP, this would actually change whenever the component where we use HTTP, so whenever ingredients re-renders, and therefore send request would change on every re-render there, and therefore a remove ingredient handler would change, and we would again lose all our optimizations. Since we use callback in our custom hook, we ensure that send request never changes, and we can safely add it as a dependency here. It will not change, and therefore this will not recreate this function unnecessarily, and hence our optimizations stay intact. So now we're sending this request here when we're clicking remove ingredient handler. Let's give it a try. Let's go here, log in, and click this. And you saw the loading state. That's great. Something changed. The ingredient is still there though, but interestingly enough, on Firebase, it's indeed gone. Now that makes sense because we sent the request and it's good that it worked, but we're not updating our ingredients here. That's of course the next thing we'll have to do. We're not done entirely. We have our hook for managing HTTP requests, but for updating our data in this ingredients component, we have no solution yet. So how can we update our ingredients here in the ingredients component when our delete request is done? Well, again, we can use a hook we already learned about, useEffect. Remember that useEffect runs after every render cycle. So useHTTP sends a request, and in that request, in the end, we dispatch response if we succeed. This updates the state, and therefore it will re-trigger the component that uses our hook to rebuild itself. So our component, ingredients component, will rebuild itself when send request is done, thanks to the logic we have in our hook. Because dispatch HTTP, which is coming from use reducer, updates the state. This rebuilds the component in which it is used. It's of course used in our hook, but that hook is used in this component, therefore this component rebuilds. By the way, if we would use the same hook in a different component, that other component would not rebuild because, as I said, the logic is copied for every component. They're not sharing the same data. So if you're sending a request in component A, that does not mean that component B also sends or anything like that. You're just sharing in the sense of copying the same logic across components. Here, however, we know that this component will rebuild whenever the request response is there. Hence, we can actually turn this useEffect call here into a more useful one. We can listen, for example, to the data, because we know that on our custom request here, when a response is there, we update response data, and that means that we set data here on our state. So our data changes when our response is there. Now for a delete request, we get no data, but still we'll change something here. We'll set a new value in response data, and that alone should suffice here. So in ingredients.js, we're listening to data, because in this useEffect call here, when we have new data, then I want to call dispatch, which is now coming from my ingredient reducer here, dispatch type delete, because we deleted a component in the end here, and pass the ID. Problem is, where do I get that ID from? I need the ID here on the action I'm creating, but this useEffect call knows nothing about the ID. Well, solution again could be that we add a feature to our hook here, to our custom hook. In the custom hook, we can add another field like a request extra, which initially also is null. Now that extra can be set when the request is sent. There we can set extra to action extra, let's say. So I expect to have an extra field on the incoming action. We're dispatching the send request here, and there we can send set a extra, and I expect to get this from outside. So as an extra argument in the send request function, I get my request extra, and I'm storing this in my state here. So back to our ingredients component, when we call send request here, I send no body, so I pass null here, but for request extra, I forward the ingredient ID. So now this ingredient ID gets added to send request. In the hook where we define this function, we then store it in the state, which is the state for this component, right? And therefore, we can now also return that request extra here in the data by getting it from our HTTP state extra. And that means that in the ingredients component, there, we can also extract request extra from the result of use HTTP and now use that here in useEffect. So that the ID I need to provide for the delete action here actually is my request extra, because we know that we'll store our ID in request extra when we send that delete request. Once the delete request is done, once the response is there, data will be emitted. Hence, this effect will run, and then we can dispatch this delete action, which adjusts our ingredients. So here, let's add request extra, and this should work. Now let me also step in here for a second and make it really clear that it can be strange to think about HTTP requests like this at first, that we're sending them somewhere and we're handling the response somewhere else in useEffect here. Nonetheless, this really embraces the concept of hooks after all, and whilst it can be strange to look at a HTTP request like this initially, it actually makes handling it much more elegant in the long run, I believe, because you can clearly see in your code where you're handling results of your request, where you're changing your data, and where you're just dispatching that request, where you're sending it off, so to say, with send request. Nonetheless, and I want to emphasize this here, an alternative would have been that the send request function we're returning in our use HTTP hook, that this send request function, for example, returns the normal promise the fetch method, the fetch API, always gives us. So that in the places where we call send request, we can add a then and a catch block, and then simply still do our logic in these then and catch blocks instead of using useEffect. This approach here of splitting the sending of the request and the handling of the response can be more confusing initially, because now you have to care about getting things like that request extra from the I send my request place to the I handle the response place, which is our effect here. Nonetheless, in the long run, as I said, I think it leads you to write cleaner code where you split your responsibilities and where you just have to switch the way you think about it, and then you'll actually have no problems with that approach. Just be aware that if you're not liking this approach at all, you could return a promise in your HTTP hook inside of send request there, and then simply chain all your response handling logic after send request in this component, in this ingredients component. You could do that, but using this approach here with useEffect handling the response simply is the approach where you really embrace hooks and use them to their fullest potential. Now I ran out of ingredients, so in order to test this, let's first fix the add ingredient handler now. In add ingredient handler, thus far we're also dispatching a send request and so on. Instead now we call send request, which again is this function coming from our custom hook here. So we call send request. The URL is of course the same URL we used down there, so I'll just copy that. The method here, since we add ingredient, will be post. The body will be that body we had before, needs to be JSON, so let's use JSON stringify. And here I need no special extra, so I won't pass that. So this again calls send request, and just as before, this goes to our hook, executes this function, emits this event, and once the response is there, emits this response event where it stores the response data. So now again, we can use our effect to react to that data in the ingredients.js file and update our local ingredients based on that data we got back. So here we have useEffect, which reruns when the data changes or when the request extra changes. And we then always dispatch a delete request. Now that's probably not what we want here. Well, in the end, we can find out what should be dispatched. We know that if we have a request extra in our application here, we want to dispatch a delete request because we only use that extra thing for delete request. So if we have extra, if that's not null, then it's a delete request. And to make sure that this gets cleared for every new request, I'll go to my custom hook and actually set extra to null here when we send the request, but instead store it on the response. There I'll set extra to action extra, and that means that further down in our custom hook, we no longer append the extra when we send the request. So I'll get rid of this here. Instead, we append the extra once the response is there. So a tiny tweak here so that in ingredients.js, we know if we have an extra, then we're deleting. Else, in our case, thus far, we're adding. So here I can dispatch, well, basically what we did before. So let me scroll down. Can dispatch this here. So let's copy that and use it here. Remove all the comments. Now, of course, here I'm relying on some data from the response. The good thing is we're getting that data. So that should be data.name because we're storing whatever response data we're getting in our custom hook. We're storing that. We're sending this here along with our action, and that gets stored in our state there. So we store response data in data. So the good thing is we have access to this. But for the ingredient, which we also want, we're missing that. Now we could send this along as a request extra, of course. But then this check here wouldn't work. Still, let's use request extra here and then worry about this in a second step. So request extra should be the ingredient which gets added. So an add ingredient handler where we get that ingredient, which just misses the ID. I now will forward that ingredient as an extra. But now since we have extras for both deleting and for adding, we need a different way of differentiating these two effects we're handling, the two results we're getting back from our hook. And therefore in the hook, I'll add a new field, the last one, here to my state, to the initial state. That's the identifier. Initially, it's null. But we send this, when we dispatch the send request, let's say, then we set identifier equal to, and I expect to get an identifier as an argument, a request identifier maybe. So I'll set this here, I pass this to the action, and in the reducer, when we send this, I'll set identifier here equal to action.identifier. So now we can append an identifier to every HTTP request in the end. And that's just what I'll do in ingredients.js when we dispatch, when we send the request here for adding an ingredient. I'll name this add ingredient. The identifier here is totally up to you. You can use any identifier you want. Can be a string, can be a number. I'll use add ingredient as a string. For removing an ingredient, I'll use an identifier of remove ingredient. And now we can use these identifiers in our effect to clearly identify our logic. So let's get the identifier from use HTTP. Let's make sure we return it there. So in our custom hook at the bottom, where we return everything, there we should also return the request identifier from HTTP state identifier. Now, since we're returning it here in the custom hook, we can pull it out of the return value here in ingredients.js, request identifier like this. And now with it pulled out, we can add it as a dependency to use effect. And then here check if request identifier is equal to, what did I use? Remove ingredient. That's my identifier here for deleting. And for adding, I used add ingredient. So here I'll check else if request identifier is equal to add ingredient. Otherwise, we'll not do anything. So this should now be all. And I know it was a lot that we need to also add ingredients. So let's log in here. And let's add a couple of apples here. And I get an error. Can I read property name of null in ingredients.js line 43? Do you have any idea what could be causing that? Well, it happened pretty fast if you saw that. So the problem is that useEffect runs after every render cycle. And when does this component re-render? Well, it re-renders, for example, when our custom hook here does something, when it dispatches the send action, which actually sets loading to true. That causes ingredients.js to re-render because we're using loading in there. Makes sense, right? Now, since that is the case, we want to make sure that we don't just check the identifier here before we dispatch actions, but we also check whether we're done with loading. Because if we're loading, then we might have data, but we're not done loading yet. Yes, data will only be set if a response is there in our custom hook here. But when we dispatch the first action, we also see data for the first time. So just watching for data changes alone here won't do the trick, especially since request extra and request identifier also might have changed, and hence the effect will rerun. So here we need a more granular check. We can check if we're not loading anymore. And of course, that means that we now need to add is loading as a dependency here to use effect. And we have that identifier here. And down here for adding, it's the same. We're checking for not loading and the identifier is add ingredient. In addition, I also want to ensure here that we got data so that this is not null or that we have no error. That's the better check probably. So we should also add error here. It's also a check that makes sense for deleting. I want to ensure that we have no error here. So now let's save this, log in, and let's add some bananas here. And this looks good. This looks way better. They're getting added. We can see them here too. And this works. And now if I delete, let's say the apples, this also is looking pretty decent to me. It now works with the help of our custom hook. So now we started working with our custom hook. That now also means we can clean up this component a bit, remove some of the code we had in there before, basically everything we commented out there. Now for add ingredient handler, you will also see that we're getting a warning here. There are some green squiggly lines that we're missing a dependency, send request, and indeed, we should add this here. Now add ingredient handler, the same as with remove ingredient handler, send request, thankfully, is wrapped in use callback in our custom hook here. And therefore, this will not rebuild or will not be recreated for every rebuild of the component. And therefore, remove ingredient handler, which also uses use callback, is not recreated. And hence, our optimizations of child components stay intact. And what we're not handling is errors or clearing errors. That's not something we're doing. We want to do that with the help of our custom hook here as well. Now we're setting an error here if we're getting one, but we got no way of clearing it. I will actually register a new case in my reducer in my custom hook, which I'll name clear. And there, I'll return a new object. And essentially what I do there is I'll just return this new initial state. So I'll cut it here, create a new constant up there. Maybe name this initial state, sounds like a fitting name, and that is just this object. And then here, in the clear case, I simply return this initial state object from above. And it's the same initial state object which we can use down there for initializing the reducer. Whoops, and we need no curly braces here. And therefore, we can get rid of that old clear case. The new one does the resetting we want. Now, clear is something we can dispatch, but we're never dispatching it anywhere here. So I'll create a new function here inside of my custom hook, clear, or whatever you want to name it. It's a pretty straightforward function which uses dispatch HTTP and dispatches an action where the type simply is clear. No data needs to be appended, nothing like that. I'll also use callback here to avoid that this gets re-rendered. We got no external dependencies, so this is an empty array. And now clear is a function which we can also return here. So I'll return clear as a key value pair in that object we're returning overall from our custom hook. And now in our component, we can get access to clear by simply extracting this as well as a property from our use HTTP result, so from our custom hook. And now in clear error down there, all we have to do is we call clear like this, or we get rid of clear error here entirely. And down there on close of the error modal, we just point at clear, which is that extracted function we're getting from our custom hook, which is already wrapped in use callback. So now let's test whether that works by going again to the delete handler, removing the S here to force an error, log in, Click on bananas. That's looking good. We can handle this. We can hopefully still add new apples. So that's all working. If I fix the error, of course, deleting will also work again. So if I delete my apples, that's looking good. So now we're using the custom hook here. Now another place where we can, of course, use it is the search component. In the search component, we're also sending a HTTP request. So there's no reason to not also use the hook there. To use it here, I will import it, of course. Use HTTP from hooks HTTP.js. And then just as before, call use HTTP up there. And then extract some data from there, which we're interested in. Now that might be less data than before. I'll keep it a bit simpler here. I'm interested in loading. I'm interested in data. I'm interested in potential errors. And I want to be able to send my requests. Since I handle errors, I also need the clear function. And now with all of that extracted, we want to send a request here where we previously called fetch. So I'll call send request here. And my URL is, of course, the same thing I had here before. So URL plus query. Method here is get. It's a get request. We need no body. We need no request extra. We also need no identifier because in this component, this is the only request we're sending. So we will always be able to identify it. And hence, we can get rid of all that logic here. I will keep that transformation logic because we'll need this in a second. And I will just cut this here. So now, for now, I'm just sending the request here if we decide that the time is ripe. Now to handle the response, I'll again use another useEffect call. By the way, the position, the order of the useEffect calls doesn't matter here. And this should, of course, execute whenever we got data, but it will also depend on loading and on an error. Because in here, I want to check if we are not loading and we have no error and we have data, let's say. Then if that's the case, then we know we got some data back. Here I will now add this transformation logic. Response data is now just the data we got back. So we can simply replace the response data with data. And then we call onLoad ingredients. Now onLoad ingredients, therefore, of course, also is a dependency here. Oops, onLoad ingredients. That's also a dependency we need to add because we're calling it here. Now in the first useEffect call here, we depend on entered filter, we depend on the ref, of course, we depend on no more on load ingredients, but instead we now have a new dependency which is send request. So we should add this because we're using this function here. And functions are normal dependencies, just like other values. Since it's wrapped in use callback in our custom hook though, it will not trigger another call of useEffect. And that's exactly what should be the case. So now last but not least, we're doing all of that. Let's now also add error handling here. For that, I'll import the error modal from UI error modal. And if I now go down to the JSX section here, above that card, I'll check error if it's there. If we do have an error, I will render the error modal. And in the error modal, whoops, that should be 2 ampersand signs. In the error modal, I want to output my error then, which is the message. And on close of that modal, I want to call clear, right? Which is my clear function coming from my custom hook, which I'm extracting here. So now this is all being done here. Now to also show a little loading indicator, let's say between the label and the input, I'll not add the loading spinner here. It would actually distort the interface. Instead, I'll just check for is loading. And if that's the case, then I want to output a span with the text loading in there. If we save that and we log in, you see loading here as a text. And you also see this if I type here and then await. Like this. And therefore, this seems to work correctly. And if we check the network tab, we also see no infinite amount of requests there. Let's add some apples and then update the filter here. So that's all looking pretty good to me. And now we're using the custom hook also in the search component. Now, I know that especially this custom hook thing can be confusing, also because we built a quite complex custom hook here. You can definitely have simpler ones than this one, but I wanted to show one where you can learn a lot. The idea of custom hooks is that you share logic, not data. So what we do here is we share logic that we use in both the search and also in the ingredients component. And when we send a request in ingredients, this doesn't do anything in search, and the other way around as well. This is how it should be. You're able to share stateful logic across components. And it is stateful because in our custom hook, we're using useReducer to manage some state. And when we dispatch a new action here, this actually triggers React to rebuild the component where we use the hook. So we're not having a regular JavaScript function here, but a function where we can do certain things that will lead React to rebuild the component in which we're using this function, this hook. That's the idea of hooks. And whilst custom hooks can be confusing at first, they can be very powerful because we were able to move all of that HTTP logic out of this component, and instead we just send off some requests and we handle the responses in useEffect. And that, of course, also is a pattern you have to get used to. Normally, you would expect send request to return a promise and then use then or async await to handle this. And you could do this, by the way. You could absolutely have send request return a promise. Here it's not returning anything. Well, we could, of course, return the result of fetch, and now send request would all of a sudden return a promise. You could do that, and you would be able to implement this in a totally different way. You would be able to simply listen to the response here and handle a response here instead of doing it in useEffect. This split into a place where you send it and then useEffect where you handle it can be especially confusing at first, but this actually embraces hooks and uses their full potential. Because I believe it's a very clean code in the end, where we have a clearly defined place where we change some data in our component here, and we could have multiple useEffect calls, of course, if we have multiple side effects. So we have a clearly defined place where we do that, and we have another place where we dispatch our actions, so to say, where we send our requests. Again, it is something that certainly takes time getting used to. It's not a must-do. You could return a promise and use your regular flow, but I think this split is very nice, very clean, and most importantly, this overall use of a custom hook and of hooks in general allows us to write very clean code with clear responsibilities, which can be challenging at first, but which ultimately will allow you to write better, cleaner, and probably also better performing applications.